you so much, sir. I will start with my first day content straight away. Okay, I'm sharing my screen again. Give me a minute. Okay, so yeah, so I hope you can see the PPT now as I can also see. So my topic, the first topic for today is going to be systematic review and meta-analysis. So we have divided the sessions. I'll tell you what we are doing today. The first session will be systematic literature review. So by the end of this 1.5 hours of session, you will be able to write a systematic literature review paper. Okay, even if you do not know meta-analysis. In the next session, I will go to meta-analysis and calculation of effect size. In the third session, we will go to fixed and random model and heterogeneity parameters. So this is how we are scheduled today. Okay, tomorrow when I come in the morning, I'll tell you about tomorrow's session. Now, systematic literature review and meta-analysis. So let me introduce you to, just a second. Okay, this is the plan. What is a systematic review? When I say systematic review, it sounds very similar to review of literature, basically. So you might ask that what's so new about systematic review? I mean, all of us know how to do a review. We learn it in PhDs, we learn it in research papers, we see it in A-grade papers. So what is this systematic review? By the end of this 1 hour 15-minute session, you will really feel that there's a difference between systematic literature review and normal review. A systematic literature review, as the name says, is collection of a study, collection of a set of studies related to a given topic, reviewing all the studies and analyzing their results. So what is systematic literature review? Systematic literature review is studying 200 papers from the past 20 years. I repeat, systematic literature review is studying 200 papers from the past 20 years and analyzing them and finally summarizing them. This summarization could be done merely qualitatively. That is when it is called systematic literature review. This summarization could be done through quantitative techniques. That is when it's called meta-analysis. Okay, so what is systematic literature review? It is collecting all those studies from the past 20 years, summarizing them, analyzing them, and reporting what has happened about these studies in the past 20 years. Okay. Why systematic literature review, or why I started this topic primarily was because many A-grade journals today have special issues on systematic literature review and meta-analysis. And the moment I saw these special issues, I came to know that this is one technique probably which is becoming very famous. So the papers that I saw mostly in systematic literature review was, for example, there is a theory called theory of planned behavior. So a lot of research has been done on this. A lot of research has been done of it. Rather, I remember one editor writing to me and saying, on one of my papers based on theory of planned behavior, he said, this theory is redundant. Redundant as in, we no more use it. So you can imagine the amount of research which has been done on theory of planned behavior. And you can imagine what the summarization of all that research, how much time, how much effort it will take. And that is what we call systematic literature review. Okay, it can be done only on topics which have a lot of data. Okay, I will explain this further. But for a minute, I would like you to get to Google Scholar just to explain how to select a topic of systematic literature review. Okay, just let me check. Yeah, it is visible. So what we do is, in systematic literature review, we have some database. Here I'm using Google Scholar, but you will have an access to database, maybe Scopus, Web of Science, ProQuest, whichever database you have an access to. So I'm here going to Google Scholar, and the first thing you have to do is select a topic for systematic literature review. Mind it, unlike a normal research paper, when I say normal research paper, there has to be a gap. So, I pick up variables which are very niche, very new. People have not heard about it, because if I test them on some statistical technique, they'll get published. So initially when I started, I'm just narrating my experience, because this is not written in any book. Okay. So my area is consumer behavior. My area is marketing. And there are two new areas which are coming up like fire when it comes to marketing. One is neuro marketing. Okay. Now this is a new area which is coming up. Now, generally when I make a paper, what do you see? You see a new area. So I also saw a new area. I said, okay, this is a new area. Plus I had learned a new technique, systematic literature review. So I said, okay, now I'm going to write paper. I'm going to do a systematic literature review of neuromarketing papers. So I just typed neuromarketing papers on Google Scholar. And when I went through these papers, I got merely 10 papers of neuromarketing. All 10 papers were speaking about different variables. So I could not do a systematic literature review on neuromarketing. The point I'm trying to drive over here is systematic literature review or meta-analysis is done on a study which has been happening from the past 20 years. It has been happening. There has to be data. There has to be some at least 200 papers on that topic. And generally when we write paper, what do we see? We don't see that on our topic there are 200 papers. No, we rather see that it should be a niche. It should not have papers. So this is a difference in approach when we are selecting a topic for systematic literature review. Now let me show you another topic. Very, very common topic in marketing. You must have heard about it. Customer engagement. Okay, so let me check if there is a meta-analysis. See, I'm going to start a paper first. Let me check the scope. The first chapter, introduction, I'll have to explain to the editor whether there is a scope or not. So I go to customer engagement and meta-analysis. And here I find that already, look at paper number 1, paper number 2. There are still others, paper number 5. So I see that on customer engagement, already a meta-analysis has been done. What is meta-analysis or what is systematic review? Summarizing the 200 papers of the past 20 years. Now, look at the first paper. It says Journal of Academy of Science, which of course is the #1 journal, and it says 2020. So if some author has already summarized customer engagement as a topic in 2020, how do you think I am going to add on it in 2021? He's already summarized it. Leave this topic. Do not use it for systematic literature review. Do not use it. Do not use it. Okay. So vis-a-vis this, let me come to another topic. Let me come to another topic. So I generally work on consumer behavior. So these are the topics I get lured by. Okay, so suppose this is the top, religion on purchase intention. Not even a single paper. Please see the first 4 search. This is what you have to do on Scopus. This is what you have to do on ProQuest. This is what you have to do on Web of Science. Whichever database you have an access to, this is what you have to do first to select a topic, whether you should be going for a systematic literature review or not. Religiosity, not a single paper. Not a single paper, which means religiosity and the impact on purchase intention has never been summarized. I will be the first one to do it. So please select this topic and start collecting papers on this, and we'll go for an SLR or a meta-analysis. So this is how, this was just to explain how do you select a topic for systematic literature review. Now we will come to how systematic literature review and narrative review are a little different. So I generally explain the difference between narrative review and systematic review with this example. Narrative review and systematic review. Now, suppose you want to make a polo team. Okay, all of a sudden, you want to become rich and you want to make a polo team, and you want this team to win because suppose it's a part of the game. It's a part of make a polo team, and you're looking for horses. Okay, so in a polo team, the most crucial element is the horse. Now, I go to a vendor. I'm just giving you, forget what is a narrative review, forget what is systematic review. I'm just giving you an example, just hear it out. So when I go to a vendor, I go to the vendor and say, okay, I want a good horse. Okay, I want a set of good horses who could play polo, or I want to make up a team. So the vendor starts describing the horses. Okay, so I have two vendors over here. One is on the left side. He says, ma'am, the horse is brown in color. He's one of the finest breed. He has won over 500 races, has a rocket bolt speed. He's one of the best. You will not get a better horse than this, so on and so forth. Okay. Another method of describing this, another method of describing is what he's done, what the person has done on the right side, where he says, ma'am, I have somewhere around 25 horses. Okay, somewhere around, just give me a minute. Just give me a minute. Sorry, I have a little bit of cough. Sorry. So suppose there is a second example where the vendor says that, ma'am, I have somewhere around 25 horses, and I'll give you the power of each horse. So one horse is 0.3, another horse is 0.5, another horse is 0.7, and there are three horses which are 0.9. Now the decision is very simple for me. I will go for the three horses who are 0.9 magnitude. Okay, so in a narrative review, let me show you an example, and you can, just a minute, you can read it also. Before I go to the differences, just read the example of a narrative review. This is a narrative review. In a narrative review, I don't have to justify why I took these authors. Just look at this narrative review. This is a normal review you see in research papers. So look at the authors: Kabelan, McCarthy, Kitzner, Karpinski, Junko, Mellett, Otswo, and Lau. That is it. So we have some 7-8 authors. Nobody will ask me in the paper why I selected them. Okay, ideally I select them because the past 5 years I take the recent research. So there's a bias in narrative review. Number one, I take the most popular. Number two, I take the people who have presented their studies only in the past 5 years, latest research. In systematic literature review, there is no such bias. Number one. Number two, I have some 7 to 8 authors over here. In systematic literature review, I have some 200 authors quoted. Number three, when I select these 7 to 8 authors in a narrative review, I don't have to justify it to the editor. But when I select some 200 authors in systematic literature review, I have to justify. I'll show you the research methodology of a paper, of an SLR paper, and you'll see that the research methodology, the explanation of what I took and what I didn't take, takes some 3-4 pages in a research paper. So in a narrative review, it's purely qualitative, it's subjective. You don't have to defend the choice of authors. You don't have to put in 200 authors. Okay, and this is absolutely subjective. So if I'm writing a narrative review, I might take McCarthy. If you are writing a review, you might take Belk. If somebody else is writing a review, they might take Sheeran. But in a meta-analysis paper, when you're taking a set of authors, ideally, I should get the same 200 papers. You should get the same 200 paper. Another person should get the same 200 papers. Okay, so that's the difference between if you can see what is narrative review. Now I'll tell you what is systematic review, and you'll find it to be a much more lengthier, complex process vis-a-vis narrative review. So I feel narrative review is very easy vis-a-vis a systematic literature review. Now, this is these are the stepwise descriptions of steps in a systematic review paper or a PhD thesis, whatever you're trying to do. The first thing is determine a research question. This is one phase I have already explained in Google Scholar. Okay, so I just took you to Google Scholar and I explained to you that how do you decide on a research question. The key points over here will be that I will not take a topic which is new. In marketing, I will not take neuromarketing. I will not take storytelling. I will not take gamification. These are three papers which are going on, but they are going on some other technique, not on SLR, because I don't have enough papers. I don't have 200 papers in the past 20 years for gamification in marketing, for artificial intelligence in marketing, for neuro marketing. How does the pupil size increase of the customer when he sees my ad? I don't have papers. I don't have data to do a systematic literature review. So let's just leave these topics and come to topics which have been studied a lot. For example, in my domain, the impact of ethical concern and purchase intention, the impact of religiosity and purchase intention, the impact of attitude and purchase intention, the impact of subjective norm and purchase intention. These are the topics where you will get 200 papers, and it is only over here that you can do an SLR, period. So determine the research question. I just took you to Google Scholar. I told you how to determine the question. 2, assemble a research team. Very crucial. To get these 200 papers, you will have to go through, I'll just go through the PRISMA, which is a process. To get these 200 papers, you will have to go through some 600 papers to reach here. You'll have to fully review some 600 papers to come down to these 200. For that, you need a research team. You cannot do it alone. There is one question which some PhD students ask me that I'm doing a PhD alone. So how will I manage that? In that case, your reviewer becomes your guide. Okay, so when you review a set of papers, you can give it to your guide and see that, ma'am, have I selected the right paper? The worst thing that we can do in a systematic literature review is bias. We cannot have a bias. Published, unpublished, A grade, B grade, new, old, famous author, not famous author, India, Europe. The only thing we can't do in a systematic review is a bias. And to remove that bias, we need a team. When you see SLR papers, you will see they actually say that there was a three-member team which was constructed. They also say that these 600 papers were shown to all of them. Then there is a value which calculates the agreement level between those three and you as a researcher. So these things are to be explained. So they have to be done. We can't skip these steps. Number 3, determine if there is any registered or published systematic review on your topic. So I started with customer engagement. I took you to Google Scholar. There is a published systematic review, and then it's done when? It's done in 2020. So if I want to write a paper in 2021, I definitely cannot take that topic. It's not possible to take that topic. Develop and register a protocol for the study. Now, this is something very new in systematic literature review. Very new, especially when it comes to social sciences. We don't understand protocol. The only protocol I know in social sciences or in academia is that we should go in formals. That's it. Okay, we should be good in our language while speaking to colleagues. That's the only protocol I know. In research, the protocol that you're going to see is extensive. And what does the protocol show? It shows the next step, which is inclusion and exclusion criteria. If at this point the editor feels you have included wrong papers or you have left out some papers, he will straight away reject the paper. So let me show you the protocol. I'll come to the other steps, but let me show you step number 4 and 5 together. Okay, because a protocol defines what is inclusion and exclusion. I'll come to this. Let me show you the protocol first. So a protocol is something like this. A protocol is a predefined series of steps which has to be taken before constructing a paper. A protocol defines the rationale, the objective, the exclusion, the inclusion of papers. The protocol gives you a leverage to exclude papers if the papers are not in the language that you understand, or you want to reject the abstracts because they are not appropriate, or the type of subjects which you feel are not appropriate. You have to list these things, and that protocol is famously known as preferred reporting items for systematic review and meta-analysis, PRISMA. Okay, so PRISMA is the protocol, and it looks something like this. It's a flow chart. It has to be given in an SLR paper. So now I hope you understand that it's not that easy as writing a basic review that you just saw. So vis-a-vis a narrative review, this is going to be a Herculean task. Vis-a-vis a narrative review, an SLR paper takes time. An SLR paper takes effort, and just see the effort. So when you search any database, and by the way, you don't have to search one database, you have to search at least 3 databases. You have to search at least 3 databases. If you're writing a good paper, you cannot say, I went to Scopus and searched, and these are the papers. No, you will have to tell the editor that you searched 3 databases. Web of Science, Scopus, ProQuest. You have to give any 3. I'm not saying you have to give these 3, but you have to give any 3. Okay, so the author is explaining, it's a method of explaining, it's a method of telling that I systematically came to the studies that I'm doing for SLR or meta-analysis. So on any of the databases, so he says I went to 3 article databases, and he says I got somewhere around 6,638 articles. Okay, and from here, on the basis of title, he starts screening. So on the basis of title, he screened out some 6,000 articles. Okay, he's left with 1,395 articles, out of which he removed 198 duplicates. Now, from where did these duplicates come? Remember, we are working in a team. Remember, me, my author sitting somewhere else, another author sitting somewhere else. They all are working on papers, and it is but natural that a paper which I list, maybe the same is listed by one author, the same is listed by the second author, so I have to remove duplications. Number 1. Number 2, I am working on 3 database. Okay, now when I'm working on 3 database, the database may also have repetitions amongst themselves. So a Scopus versus a Web of Science versus say Google Scholar. So of course the papers will be overlapping in them also. So after removing papers on the basis of title, you remove the duplicate papers. Okay, one method of doing this, if you don't want to do it manually, is Mendeley. Okay, so databases like Mendeley are very good in removing duplications. Okay, now once that is done, you're left with some 1197 articles. Now here you start screening the articles on the basis of abstract. Okay, so I have screened on the basis of title. Now I want to screen on the basis of abstract because I want to go further. Okay, now here you might ask me that there might be a possibility that I remove a paper on the basis of title, and but the paper is relevant on the basis of abstract, or that is very much possible. But we are assuming that the title speaks about the topic. Here we are assuming that when a researcher, when an author must have made a paper, he must have made a paper where he must have appropriately given a title to his paper for the readers. Okay, so I'm assuming that, and that's why we say remove papers on the basis of title. Now, some 821 papers are excluded because of their abstract. So I start reading the abstract now. And when I read the abstract, I find, okay, this is not that related to my topic. I'll give you one example of how I have removed papers on the basis of abstract. I was doing a meta-analysis paper on impact of religiosity on purchase intention. So I got an abstract where they were studying the impact of religiosity on intention to smoke. Now that is not my paper. My topic is purchase intention. Okay, so my topic is not intention to smoke, or there were papers on criminal intention. So because that word intention was there, so probably they got listed, but that is not what my domain is. Okay, so what do? I exclude them on the basis of abstract. And although the title says religiosity and intention, sometimes when you read the abstract, you come to know that this is not purchase intention. This is not talking about consumers. This is a paper which is talking about intention to smoke, or criminal intention. That is what it's talking about. Okay. Now, after screening on the basis of abstract, I come to some 415 articles, and this is when I start full text screening, and this is where I need a team very desperately. 415 articles are to be screened. Okay, tables are to be made for every article. I'm about to make an Excel sheet where I will write. I'll show you those Excel sheets as we do analysis. So in these 415 articles, when I'm screening them, I will, make an Excel sheet. There will be an author name, there will be a title name, there will be a correlation between bivariate. So I'm going to make these tables. Okay, so it's a hell lot of a work to screen some 415 articles. Okay, after fully screening them with a team of say 3 people, I discard 319 articles. Okay, and then I'm left with some 100 articles. Okay, and these 100 articles. So what do I mean by screening 415 articles? These 415 articles could be qualitative and quantitative, but for meta-analysis, for systematic literature review, you could take all 415. But if you're going forward to do a meta-analysis, a quantitative research, you need only quantitative papers. So if I am finding out, I will find out the effect size in the next session. So if I'm finding out the effect size, I only need papers which have a correlation value. So what do I do with the rest 319 papers, which are qualitative papers, conceptual papers, review papers, papers based on personal interview? What do I do with them? They are of no use to me. I need the correlation value to do meta-analysis. So I discard these 319 papers, which are either qualitative or review papers, or they don't give me a correlation value. In these 319 papers, I also discard some papers where the correlation table has not been reported. So the paper is quantitative. The paper is talking about correlation between the two variables that I need, which was religiosity and purchase intention. But the problem is that the author hasn't listed the correlation table. Now, one thing which we can do is we can write to the author. Okay, in case we write to the author and the author reply back, gives me the correlation table, I can include it, or else I will have to totally exclude it. Okay, and then critically appraisal of 100 articles. So I'm now left with 100 articles. These are quantitative articles. They have correlation values. Okay, and from here I will be extracting data for meta-analysis, which we'll do in the next session. From these 100 articles also, I have excluded 60 articles further. Now, why have I excluded? Please read. It says redundancy in data or susceptibility to bias. So I got some 100 articles. All these 100 articles are speaking about religion and purchase intention. All these 100 articles have a correlation value, but my problem is that there's a bulk coming again. So out of 100 articles, if 20 articles or 40 articles are only about Dr. Sheeran, or only papers of Dr. Sheeran, or only papers of Dr. Belk, which means I have a bias. I have a bias towards selecting a paper. I had a bias of selecting papers for the meta-analysis only from, say, popular authors. Okay, and this is the point where I'll have to exclude these 60 papers because there's a bias. So these 40 papers, out of 100, if 40 are saying only a study of Dr. Sheeran, I will have to look at it. Maybe there's a bias. Okay, maybe I have to replace these papers with papers from, say, university students, conferences. Okay, so there is a bias. Redundancy of data. So these two factors I have to see before I screen from 100, remove the 60 and come to 40. Now I have 41 studies. These studies are quantitative studies. They do have correlation values. Okay, and they are now studies which I can take forward to statistical analysis. And from here also, from 40 studies, a few studies I don't get correlation tables, I remove them. And finally, I come to 31 studies. I will do a statistical analysis or meta-analysis of these 31 studies. Okay, so this whole thing that we have done, which is pretty complicated, it takes time. It takes somewhere around at least 3 months to do this process. And I have still not even started the statistical analysis, the meta-analysis yet. Okay, so 3 months only for this process. 3 people in 3 months are going to do this process. Okay, now let me come back to the process and take you one by one. So we determine a research question. Okay, we assemble a research team. We determine if there are any registered or published papers. We develop and register a protocol. So I just showed you a protocol, okay, which is PRISMA. We develop a comprehensive search strategy informed by inclusion and exclusion. So this was my comprehensive search strategy, where I informed whether I'm including or excluding any papers, and I have to do it very, very systematically. I have to prove to the editor that there is no bias. Okay. Select studies for including based on predefined inclusion exclusion criteria. So I've done that in the protocol. Extract and analyze data. This is step number 7. From here, actually, meta-analysis starts. So I extract from these 31 papers correlation values, and I'm going to take you through calculation of effect size, heterogeneity, fixed random model, so on and so forth. And finally, update review as it is required. So once you publish this paper, okay, so once you've published this paper, that is when we say that all the review, all the review of this particular topic has been updated. So you have actually updated the review. Okay, review and meta-analysis is I'll just give you an example of research question. I generally work on theory of planned behavior, although it has turned redundant, but I'm still working on it. And the theory of planned behavior says that attitude, subjective norm, and PBC impact intention, and intention impacts behavior. So this is the theory of planned behavior. And here what I'm going to do is I'm going to collect all papers which give me this relationship. So I'm going to collect papers which will give me a relationship of attitude and intention, norm and intention, PBC and intention, intention and behavior. I'm going to take all the values of this. I will also define the research question in the form of a PICO, which is population, intervention, comparison, and outcome. Okay, so what do I do when I'm defining a PICO? Population, which means that whom am I studying? So if I am doing this study and I've done the study already for a set of population, so I'll just describe my study, the population, the intervention, comparison, and outcome. So I did it this way. Okay, this is the population I studied. So for this model that I've showed you, I took young consumers. I wanted to study if these young ethically conscious consumers are purchasing products which harm the animal. So this was my research objective. I was trying to study if the attitude of young consumers towards products which harm animals. So my population is young, ethical, conscious consumers. My intervention is uh, religiosity. So I wanted to study the impact of religiosity on this. Comparison that I did was between, and in medical sciences, this comparison can also be done between experimental group and control group. So here I did it between males and females, private colleges and public colleges, so on and so forth. And the outcome was that I wanted to know that after studying the impact of religion on the purchase intention, will I be able to, will I be able to suggest the points of avoiding of business of buying products with animal harm? Will the young consumers buy products with animal harm or not? So that is my conclusion. So when I say outcome, I'm speaking about outcomes of the research, okay, which also says managerial outcomes. Okay, so we are speaking about once this research is done. So research isn't just done to list something academically. Research is done also for listing out what are the outcomes to the managers, to the industry. So when I'm doing a systematic literature review on young consumers, so I'll take up all papers which have young consumers, and I'll study the impact of religiosity on purchase intention in those papers. Then I will compare those 200 papers on the basis of papers done on males versus paper done on females. And then finally, I will conclude the SLR paper and list an outcome. So I will say that, okay, now, uh, according to the 200 papers, I feel young consumers will avoid purchasing the animal harm products or not. Okay. So this is an example of how we define research, which is PICO. Okay, protocol I have told you. So PRISMA is the protocol we follow. It does not come from social sciences, although it comes from the medical sciences. Okay, Cochrane is the um, Cochrane has actually listed it is a database for medical studies, and Cochrane is the one who's listed the PRISMA, and we have to follow this. So this has to be given in an SLR paper, compulsorily given. Now, you might ask that what is the criteria of including or excluding papers? So these are the major criteria which we use in SLR to include or exclude papers. The first thing is that we have to define the database. So if we are doing a social science research, I will have to define the database. It could be the ABDC list, it could be the Scopus list, it could be the Web of Science list. Now, the moment you define a list, you already have selected something. So, if you have selected the Scopus list and the Web of Science list or the ProQuest list, you have already, defined your selection, that I have referred to only these databases and I'm not referring to something else. So this is why I call this selection of database also a selection criteria. Many a times when I didn't get paper from these databases, and yes, I did not get papers from these databases. For example, in my paper when I was working on religiosity and intention, I did not get papers from this database. So what I did is, whichever one or two papers I got, I referred to their reference list. Okay, I referred to their reference list, and from the reference list, I further got some papers. Okay, so that is one thing you can do. And you can always write this down that I included papers from the reference list. Another method of getting papers or including papers is contacting the authors. For example, when I enter a topic on ResearchGate, sorry, I enter a topic on the database and I see a paper on ResearchGate. So sometimes, the paper is not accessible. Okay, so I have to ask the authors to give an access to it. And what happens is that when I am referring to a topic of religiosity and I'm going to the database, it generally lists the authors who are working on it. Now, these might be famous authors or not very famous authors, but ResearchGate is such a platform, let me tell you, that starting from a student who puts a paper to a young researcher to a very famous hotshot researcher, all people are there on ResearchGate. So authors of published papers could be contacted. Okay. Also, many a times when you're browsing the Google Scholar or browsing Scopus or browsing such databases, you get some unpublished studies. Okay. And in meta-analysis, we say there shouldn't be a bias. So yes, any unpublished study, and this might sound a little surprising and a little shocking, but unpublished studies, okay, can also be taken as a basis into meta-analysis. So basically what you're trying to do in a systematic literature review or meta-analysis is you're trying to summarize studies. Now, whether they are published, whether they are not published, whether they are from a very famous author, or whether they are student dissertations, you're supposed to be taking all papers. Okay. Now, a few of you might ask, what is the authenticity? Okay, so here we are not establishing an authenticity. We are trying to collate the data done in the past 20 years. So if there is a student of a university and who has a thesis or a dissertation being put up on ProQuest, there are times when I've read papers and they say we selected the ProQuest because we wanted to include dissertations or theses done by students. Okay, so this is actually, I've read it in research papers that they took ProQuest purposely because they wanted to take dissertation from students. So even those can be taken. Conference papers. Now you might say that conference papers are not published, so that's okay. Even if they are not published, they can be taken. So all sort of unpublished research, can also be taken for systematic literature review and meta-analysis papers. Okay. Another criteria of selecting is my research objective. I just showed you on Google, so religiosity and purchase intention. So I am looking at a bivariate relationship. I'm looking at religion and the impact of purchase intention. So obviously, I will only select papers which are talking about it. So I gave you an example of a paper which studied about religiosity and intention to smoke. So obviously, I'll not take that paper. I will take a paper which is of my domain. Now, if I feel that a lot of study has, suppose there's a systematic review and meta-analysis which has been done on religiosity and purchase intention. Okay, suppose in 2020, already somebody has listed a systematic review and meta-analysis on religion and its impact on purchase intention. Now, what can I do? I can take up a systematic literature review or meta-analysis study on religion and purchase intention of sustainable products. I can do that. I can do a meta-analysis only and only that person who must have done a religiosity and a purchase intention analysis must have done it from all sorts of categories of products. I can make it only for the niche, only for the sustainable products. Okay, and this is how I select papers. So when my research objective is to make a consolidation of research or systematic review of a research for only sustainable products, obviously, if there's a paper of religion and intention on mobiles, normal mobiles which are not sustainable, I will not take it. Okay. Coded correlation should be available. So as I said, the papers which do not have a correlation matrix, I remove them. I actually remove them because I need correlation as a value. So either correlation or you will come when we do further, there is a p-value which can be taken, there is a t-value which can be taken, there is a regression coefficient, a beta coefficient which can be taken. So these 4 or 5 values, if they are there in the paper, well and good. But if these are not there, what use is the paper to me? Even if it is a perfect paper and it has reported some model statistics and all that, it's of no use to me. So I will have to remove these papers. Tabulate the characteristics and effect sizes of the studies that were included. So this is making the Excel sheets. I'll come to this. So primarily what we have done in this session is we have differentiated between a literature review, or what we call a basic narrative review, vis-a-vis a systematic review, vis-a-vis meta-analysis. Now, many people feel that systematic literature review is a part of meta-analysis, which is a wrong notion. Meta-analysis came in step number 7. Before that, it was not even there. So if you want from step number 1 to 11, you could stop at step number 6. Don't do a meta-analysis, write a paper, it will still be known as a systematic literature review paper. So the broader area is systematic literature review. Within systematic literature review comes meta-analysis. It is not vice versa. Okay, and the difference between a literature review and systematic review, I hope it's clear. Right in the beginning, I showed you an example of a narrative review. I showed you an example of where some 6-7 authors were listed and a very qualitative method of explaining them was done. I've shown you that. And vis-a-vis the whole process that I've explained in the past 1 hour, you can imagine how exhaustive the systematic literature review is. We have to go by protocols which have already been set, which is the PRISMA. We have to go by defining the research through a PICO. We don't do that in general papers. We don't define our research question with the help of a PICO. We don't do that, but in papers that is generally done. Okay, and meta-analysis will start from step number 7 when we get those 31 consolidated papers. We started with some 6,600 and something, if you remember, in the PRISMA. So now we have come to those 31 papers, and from these 31 papers, I'm going to extract correlation values and go on with my meta-analytical study. Okay, so this is what is the process of this. Now, why meta-analysis? I mean, why don't I stop at systematic literature review? Is because meta-analysis is one method by which I can extract data, I can contrast, combine results from different studies. So I give a very simple example based on what is happening nowadays in the COVID era. So all of you know that there is a COVID vaccine which has come up, and in different countries it is being tried differently. It's being tried differently. So the COVID vaccine, when it was tried in Norway, there were some 29 deaths. The same COVID vaccine in some other country is leading to paralysis. The COVID vaccine by the company, the Indian company in India is doing still better. Okay, it is doing still better. So there are varied results, you know, and these are all experimental studies. These are all statistical studies. So there are experiments being done with the COVID vaccine and the people on whom it is being given, the frontliners as they call them. And we want to contrast these studies. See, tomorrow if I say, should the Pfizer vaccine, COVID vaccine come to India? Can I just say, okay, because it has been sanctioned, it can come to India? No. In Norway, The same vaccine led to 29 deaths. So the method of comparing, contrasting these statistical results or these numbers or the numerical values or the effect of that vaccine, which we will take as effect size, the effect, studying the effect, okay, that is what is meta-analysis. It is quantitative, it has a magnitude. So when we talk about this COVID vaccine, we will say, okay, in Norway, the effect is 0.1. Okay, in some other country, the effect is 0.3. In a third country, the effect is 0.2. Now, when I consolidate all these three and get a weighted average effect size, maybe the weighted average effect size, suppose, is 0.3, 30% chances of success. Would you people ever want to bring such a vaccine into India and be applied on Indians, especially the older generation? So that is the managerial implication or the outcome. So to come to a conclusion, and you know, meta-analysis is a field which came from the medicine line. It is not as easy to say that, okay, attitude affects intention or attitude does not affect intention. No, it is not that way. It is not that easy in medical sciences. It's a matter of life and death. Thus, the effect or effect size of a particular vaccine on a patient is a very, very crucial thing. So when you're bringing a vaccine to India, I will go through those 200 reports where that vaccine of Pfizer has been applied on patients. I will see the effect of the vaccine in a magnitude called 0.3, 0.2, 0.4, 0.5. Consolidate them, summarize them, and then I will conclude, okay, overall effect size 0.5. No, I can't bring it to India. Overall effect size 0.8 and above, okay, I can bring it to India. And it's not I who's saying this. It's not I who's saying that the effect size will be this much, so bring it in India. There are proper authors who have listed the effect size and whether the effect is low or moderate or high. And based on that, we will interpret the findings of meta-analysis. But having said that, meta-analysis is only the quantitative part. It comes after step number 7. Okay, so an SLR paper can be done even without meta-analysis. So I generally explain meta-analysis with this example. So coming back to my POLO team, okay, you see all sorts of horses. You see tall horses, you see dark horses, you see small horses, you see fat horses, you see thin horses. You see all sorts of horses over here. Replace these horses with research papers. Now, for a particular topic, say religiosity and purchase intention, I have a paper which has a sample of 600, so it becomes the fat horse. I have a sample size, I have a paper which has a sample size of 100, it becomes the small horse. I have a paper of a very popular author, Dr. Bell, that becomes the black horse. I have a paper of a student, so that becomes a brown horse. What I'm doing is I'm trying to create a polo team of all sorts of horses, or should I say, all sorts of research papers, big, small, published, unpublished, famous authors, students, till the time I get a correlation value of religion and intention, I will be taking it. Okay, so that is the essence of meta-analysis. And I'm just unsharing my screen for a minute to show you a research paper. I just wanted to show you a paper. Sorry. So I'm just sharing this paper. Yes, so I hope it is visible. I hope it is okay. Yeah, now it is visible. So this is the paper. It is a paper on systematic literature review and meta-analysis. Okay, it has the full process. Okay, it's talking about mental health. Just taking you through this. The author describes the background, why he's doing it. He describes the method, and look at the method. Look at these. The research method in a systematic literature review and meta-analysis paper is very crucial. Okay, you have to describe from where you took data, what data you took, how you what were the parameters of exclusion. Look at this title of an abstract, full papers, methodological quality. He's defined that. Okay, I'm dead sure none of you do this in your papers when you're doing a basic narrative review. Do you people go through such an extensive process in selecting those 7 authors that I just showed you in a narrative review? You don't. We don't. Okay, and then of course the results. So we start with an introduction in a review paper or a meta-analysis paper. The introduction, like any other paper, consists of the gap. I have actually taken you to Google Scholar to show you how to select a topic and then define a gap. The method part is the most lengthy in a meta-analysis paper. Now here I have what he calls the eligibility criteria. So I'm just showing you one of it. Just look at this. Language was limited to English, Spanish, Portuguese. Have you people ever in any other paper defined which languages you took as review? In narrative review, do we define? We don't define. Here we have to say why we excluded these papers. Okay, and you know, this is not wrong. I mean, the fact that you say that the language was limited to English, Spanish, and Portuguese, this is a part of the methodology. It's not a part of limitations of the paper, by the way. This is not a limitation, but you have to tell in an SLR paper to the editor how you selected papers. That's it. Okay, let me go further. All that I have told you, I'm just showing it to you in the paper. So this is all review. This is still research methodology going on. So see, he says I took the papers from these databases. He very clearly shows the database which he took up. Okay. I also told you that in a research paper, they always tell about their team and they say how they selected. So see, he says I had a team of 2 reviewers. They examined the title, they examined the abstract, they excluded so and so paper, they included so and so paper. So, you know, you just cannot finish by saying, I included so and so paper or I excluded so and so paper. You have to show that I had a team, I had a set of experts. He's named them also, of course, with due permission. With due permission. Okay, so he says I had 2 reviewers. He names those 2 reviewers. Sometimes they also say that so and so was had so and so years of experience in meta-analysis papers. So they always define, and then they say this is the team which selected. Okay, sometimes they also give a Cohen kappa value of the consensus of the authors. Okay, then they come to what all they extracted. Step number 7, if you remember. Step number 7, what all did you extract? So they say they have extracted sample size, type, frequency, duration of the intervention, scales, outcome. All this they have extracted from papers. Then they have also shown the PRISMA in a written form. PRISMA, the protocol. The database produced 4,751 articles. I eliminated 4,605 because they were not meeting the inclusion criteria. Different methodology, repeated citations, language. Thus, another 146 were removed. So imagine the amount of justification you have to give for the selection of your research articles. Okay, and finally, of course, after all this theoretical explanation comes the PRISMA. Okay, diagrammatically we have to say, and look at the database. So he says PubMed, Scopus, Web of Science, Cochrane. He exactly lists how many papers he got from each of them. Okay, so see, duplication I told you, so that there's a repetition, 155 were repeated. Okay, I just give me a minute. Let me use the so see here, repeated 155. Remember, there was a duplication. Okay, so repeated 155. What he excluded, why he excluded, he's described everything. Okay, further, just give me a minute. Okay, further, let me go further to the paper. So this is a flow chart. It's PRISMA. It has to be listed. Okay, it has to be listed in a paper. So it has to be done in a social science paper also. Further, he comes to, now this is from where actually, this he's just listed the paper. So look at it. He's given the author name, he's given the participants, he's given the sample size. As yet, meta-analysis hasn't started, by the way. This is all research methodology. The meta-analysis hasn't even started yet. So look at the amount of pages that have gone in the paper just to explain the selection, because if the editor feels the papers haven't been selected right, he will straight away desk reject the paper. Okay, so this is what they have presented. They have shown all the papers, the participants, what sort of participants they had, the sample size, the scales, everything they have shown. And then finally from here they start meta-analysis. So I'll just stop over here, because yeah, so because from here on we would need calculation. So anything till here, okay, till listing all the studies into tables and their topics and everything, this finishes what we call the SLR part of the paper. We've still not started meta-analysis. So you can see the amount of work that goes in describing the selection, the research topic, etc. Okay, just give me 1 minute. I would like to share one more paper. This is one more paper that is being done on a topic of social sciences, theory of planned behavior. It is a social science model, okay, and theory of planned behavior, which I just explained to you also. Okay, I had taken 3 variants in theory of planned behavior: purchase intention, subjective norm, and the PBC. Okay, so just look at this paper. Let me start. So introduction, of course, will be the gap and what will be the managerial implications of the same. And then we will come to method part. So look at the method. So here comes the PICO: population, intervention, comparison, outcome. Okay, the author has defined everything. So in a while defining a research question for an SLR meta-analysis paper, you need this thing. Okay, and then yeah, so again he says initial was through the database. He has also given the keywords that he put into the database, right? So he has given all the keywords that he tried: theory of planned behavior, theory of reasoned behavior, low fat diet, all keywords that he added to these database to search these papers, even that he has listed. Okay, he further goes to say, this is the line I was saying, he says, I have gone to ProQuest, or I have selected ProQuest specially because it has dissertations and theses which were reviewed to locate unpublished papers. Okay, and he's given the reference of Rosenthal 1978, the bias tests in meta-analysis, the publication bias tests in meta-analysis have been founded by Rosenthal. So basically, he's given a reference of Rosenthal to prove that all the studies that I've selected, published, unpublished, do not have a bias. Okay, so I have not been biased towards selecting the data that I have selected. Okay, again, same thing, two authors independently pre-screened one half of the database, titles and abstracts. He said that. So you have to say that you haven't done it yourself. You had experts to do it, and there's absolutely no bias, and all data that could have been taken. So you have that there's no stone unhurled. That is what you have to prove to the editor. Okay, and data extraction, that I think you know. So it should be, yeah. So there comes the PRISMA. Okay, there could be different formats of PRISMA in different papers. Okay, so there comes the PRISMA, and why he took the papers, why he did not. And so you can now, when from here meta-analysis starts, so I'll stop here. I'll stop here. So till the PRISMA, the whole process you've seen, and if you see now, if you go back and see that slide of narrative review, you will come to know that yes, it's very different from the narrative review that we used to do. Right, so that's about SLR and meta-analysis. I think we can, so we can open the house to questions. Yeah. Yes, sir. Okay. Okay.
You may start, Jaspreet.
Okay, sir. I'll just share my PPT. Just okay. I hope. Yeah. I think the PPT is. Just a second. Give me a minute.
It's perfectly visible.
Okay, sir. Okay, just starting. Okay. I'll just make it full screen. Give me a minute. Yeah, so we are now starting with actual meta-analysis. In the first session, we did SLR. Now let's come to calculation part, or the quantitative part. I am reiterating that I'm talking about those 31 papers, but as the session went last time, please don't take 31 as 31. Why I'm referring to that again and again is because I took you through a PRISMA. We sorted out papers, we reached 31. So I'm just trying to carry you from there. It doesn't mean it has to be 31. I'm just going through a flow, okay, of a present study. So if you see the PRISMA, we had sorted out, we started from 6,600 papers, and we came down to some 31, okay. Now we are going to start a meta-analysis of these 31. But before that, and this is a comical way of representing why meta-analysis, or I'm coming to a term called effect size. Why effect size? So let me explain what is effect size. So as sir has already told you, I was a little unwell in the morning. Okay, and I told my husband to rush and get me medication quickly because I had a seminar. So he brought an anti-vomiting tablet that he got. It's been 20 minutes I've taken it, or maybe 30 minutes that I've taken it. What is the effect of it? Okay, it's as simple, as simple. It's yes, technically we're going to go into numbers. How effective was it? The English word effective is effect size. So in social sciences, when I say attitude impacts or affects purchase intention, another paper says this, then third, then 200 papers say this. What is the consolidated effect? Similarly, in medical sciences, when I say the Pfizer vaccine was effective in Norway, effective in Syria, effective in India. So now I want to apply the vaccine to an XYZ country. I'm summarizing all these effects of Norway, of Syria, of India, and finally saying this is the consolidated effect, say 0.5 or 0.8 or 0.3, and now you can apply it to a fifth country. That is what we understand by the word effect size. Why effect size? So I got this comical representation. So there's something called p-value. I am assuming a few basic concepts like p-value, correlation are clear to you, because that is what we are going to extract from our data. So p-value, okay, significance value, in all the papers that you take, some 200 papers you're going to pick up, you will see that there's a significance value given between a relationship. Now, sorry. Now the significance value just tells you that there is some effect. What do we write in our when we conclude from the p-value? What do we write in our supportive data? What do we write in discussions? We say hypothesis 1 supported. Why? P-value less than so and so supported or not supported, which means in very simple language, this variable on this is effective or it is not effective. Simple as that. But do we ever list the magnitude of effect? Or can we say that when the p-value is 0.01, then it is more effective? When it is 0.04, it is less effective. When it is 0.05, it is even more less effective. So can we say that? We can't say that. But when we take correlation values from 200 papers and finally find out a total effect size, we can say attitude impacts intention by how much? 0.5. By how much? 0.9. By how much? 0.3. Says who? Says who? Not just me. Says a summary of 200 papers. This is what we are going to do while finding effect size. This is the purpose of finding effect size. P-values in research papers give us whether there's effect or not. Effect size in the papers, all consolidated 200 papers now, will give us the magnitude of that effect, the magnitude of that impact. So that is why effect size and not p-value. Okay, so these are the basic differences that I've just listed. Okay, and p-value, the magnitude cannot be compared. Effect size, magnitudes can be compared. P-value is just for statistical significance, yes or no. Okay, so it's like saying that suppose you say that my spouse really likes me. Okay, so p-value less than 0.05 means your spouse likes you. More than 0.05 does not like you. But Effect size tells you how much your spouse likes you and how much he doesn't like you. So you should know. Just saying that he doesn't like you is not enough in social sciences. So if I say I like a brand, okay, so p-value tells me, okay, she likes the brand or she doesn't like the brand. How much does she like a brand? If I say I like a brand called Kia in automobiles, I say I like a brand called Kia. Is that enough? Is this much? Is this data enough for the company? How much do I like it? Do I like it by say 0.1 effect size? If yes, it will not take me a minute to switch to Hyundai. It will not take me a minute to switch to Maruti. But if the p-value which is telling me, okay, I like Kia, but if that effect size, if the effect size of that liking is 0.8, what does that show? It's either Kia or no other car, and that is the amount of loyalty I'm expecting from a customer. So where p-value just tells you liking or not liking, effect size tells you how much of liking. Okay, so the details this thing is given, but I quickly after within half an hour I want to come to the software. So so this is the basic. You can get the slides and read on. Okay. Let me come to effect size. Now I'll take an example from social sciences. Therapy impacts depression. Okay, so therapy has an impact on depression. Now I want to see the magnitude of this impact. Okay, 0.1, 0.3, 0.5, and that magnitude is what we call as effect size. This is a second example where effect size is good. So I'll give you a everyday example for that matter. I don't know how many of you have ever had an experience with dietitians. Okay, now what happens is a dietitian or a professional dietitian is known to reduce your weight. I mean, all that we know about dietitians is that she's effective. P-value less than 0.05. That's it. But she is more effective for people who are already on junk, say 0.8. She is less effective on people who are already on house food, roti, dal, chawal, say 0.3. So if you go to a dietitian, you're eating home food and you are going with a dietitian, no, her effect size is 0.8, you would be mistaken. For you as a case, the effect size will change. So the magnitude will change. And if I have to judge how effective a dietitian is, I am going to list 200 of her cases. Again, please do not take that 200 value on face value. I'm just saying I will pick up 200 patient cases from that lady, whether they were eating junk, not eating junk, whether they were North Indians, whether they were South Indians, whether they were eating roti, whether they were eating chawal, whatever it is. I will consolidate and say how much weight she reduced. I'll take that as an input, calculate the overall effect size and say, okay, this lady is 0.7 effective in reducing weight. Based on what? 200 people. Here in meta-analysis, we don't deal with people. We deal with secondary data. Our people are papers. Past research papers become our people. Okay, I hope the relevance of effect size is clear. Okay, I have to come to types of effect size. Okay, you should be knowing it, although today we will only be working on the correlation effect size, our family effect size. But you have to know that how many types are there, because in social sciences, ideally we can use all types. But most of the papers that I've seen in meta-analysis, we take up correlation values. Even the sample paper I'm about to show you, after we do all the calculations of effect size today, I'm going to show you a sample paper. And when you see that table, even they have taken correlation, okay, as a input for effect size. Now, there are primarily three types of effect size, or should I say families of effect size. Ideally, there are 100 effect size. Okay, so effect size types, if I am trying to say, there are some 100 types of effect size, majorly categorized into three families. One is the D family. Okay, probably comes from the person called Cohen D, who's worked a lot on meta-analysis in the medical field. Okay, he's also given us a criteria. So when I go ahead, I'll show you a criteria. Like we have a criteria for p-value less than 0.05 and more than 0.05.
Jasprit, please unmute yourself.
Oh, sorry. Yeah. So like we have a criteria for p-value. For example, more than 0.05, less than 0.05. What should be the interpretation? Similarly, we also have an interpretation of the effect size, which has been given Cohen. Okay, so that is where he was the person who actually brought in the first type of effect size, which was Cohen D. It was used in the medical domain. Okay, till date, the D family effect size, primarily Hedges G, Cohen's D, etc., or Glasses G, these values as calculated from effect size, they are called Cohen's D, Hedges G, etc., are used in the medical fraternity. The D family effect size is generally used for medical sciences where there is an experimental group and there is a control group. Now you might ask me that there even in social sciences we have experiments. Yes, there are experiments and you can use it, but the calculation of this I will not be doing, because you can use it, but primarily what we use is the R family or the correlations. Okay, so yes, if you're doing an experimental design in social sciences, okay, you have a control group, you have an experimental group, you can go for the D family, Cohen's D effect size. The second family of effect size is the correlation family, as I call it, or the R family, where we pick up correlations. Okay, we pick up correlation values. Now, again, I hope the audience is clear about what is correlation and how to pick it up from a paper. I will be showing it, not that I'll not be showing it, but the concept of correlation should be very clear. Okay, this variable impacts this variable, correlation this much. Okay, so we take the correlation from these 31 papers. I did a PRISMA. I was left with 31 papers. I'm going to do a quantitative analysis or meta-analysis only of these 31 papers. Okay, so 31 papers, I will take correlation values. And then when I calculate effect size, it is called the R family effect size. Another type of effect size is the others. It's called the others, but it is calculated from odds ratio or log odds ratio. Again, something which deals with the medical line. But what is it? I'll explain to you just for the knowledge of major types, because sometimes when you're seeing a YouTube video of meta-analysis, suddenly it talks about Cohen D's and odds ratio and log odds, and then you say, this I didn't study in effect size, because the workshop was only on R, and there are very few videos which are on the R family. I have learned it the very hard way, thanks to Kaushik sir, who's helped me a little, but it was very difficult. There's no video of how to calculate from correlation. That was the problem. I am a social sciences person. What should I do with D family and odds risk? They are both from the medical line. I needed correlation, and there was no explanation on the YouTube for that. Thanks to books like Borenstein's, Hunter and Smith, and of course, sir's videos that I have a command over this. Okay, odds ratio, log odds ratio. Odds ratio. Okay, odds ratio and log odds ratio is an effect size where the explanations are based on events. Okay, so in the D family, I told you we work on the experimental group. Okay, so what is an experimental group? Control group, experimental group. Okay, control group or treated group. Now, within this, after giving a medication, if there is an event, what is an event? This is my control group. This is my experimental group. I gave a vaccine to the I gave a vaccine to the experimental group. I did not give a vaccine to the control group. People from the experimental group, 2 died of vaccine, the rest survived. From the control group where I had not given vaccine, 4 died from COVID, rest survived. This survival and death is the event. And when we take studies, those 200 studies where people have actually worked on the vaccine and their events, that is where we use the others effect size or the odds ratio or the log odds ratio effect size. So what we will be dealing with today will be the R family or the correlation, because in social sciences, primarily this is used. Okay. Okay, and this is about, it's all written in the slide. Whatever I've explained, it's written in the slide. The differentiation in the 3 effect sizes is the input that you put into it. So for a D family effect size, I use standard deviation and means of the 2 groups, control and experimental. For the others effect size, where I use risk ratio or odds ratio as an input. For the R family effect size, I use correlation values as my input. The only difference in these 3 effect sizes is the input. Once the input has been put into the software and we reach the next step, which is the forest plot, you will see there is no difference in the interpretation of any of these 3 effect sizes. They will all become same. And when I reach there, I'll also explain that. So, and this is the family, and let's come to the R family first. Okay, and let me start with data collection. So I've actually shown you how to get data from those 200 papers. Here I've shown you only 1 papers table. So I've actually shown you how to get data from those papers, because many people tell us that you know, you're showing us Excel sheets, but we don't know how to extract data. Okay, so I'm on step number 7, where we were extracting data from those 31 papers. Why 31? I've explained through PRISMA. And please do not take 31 on the face value, right? So on the right side, you see this is supposed to be a correlation table. You might ask me a question, ma'am, what if they have done a structural equational modeling in the paper, but they don't represent this table? If they don't represent this table, you cannot take that research paper as an input. I repeat, if you do not see this correlation table or further a beta coefficient table, okay, if you don't see this, you cannot extract data from here, so you cannot take that paper. Please remove it. Ideally, what we do is, because I have promised to myself that I'll not leave any paper, any stone unheard. So ideally what I do is I write to the author. Okay, I write to the author that, sir, there was this model proven in your research paper, but the correlation table you have not reported. Can you please give it to me? So if I get it, if I get it, well and good. If I don't get it, I just leave that paper and only concentrate on papers where I have what is the correlation table on the right side. Okay, I hope I hope you all know how to read a correlation table. So this value, 0.67, is the correlation value between subjective norms and intention. Okay, so this 2x2 paper, 2x2 matrix, you should be able to read. Okay, I'm assuming you know how to read it, because if not, then you'll not be able to extract values, right? Just give me a minute. Erase. Yes. So this is the value you will extract. Now look at the table on the left side. This is an Excel sheet that you make. This is actually the input sheet that I'm going to take into 2 softwares. One is comprehensive meta-analysis, and one is Meta Essentials, which is a macro of Excel, and it's free of cost. Okay, the good thing is that it's free of cost. So I'm going to take this data to CMA, and I'm going to take this data to the Meta Essentials Excel macro. Also, I'm going to show you how to take it there. But before taking it there, what you see on the left side is data extracted for one bivariate relationship for the 8 authors. Okay, so I had some 8 papers. Okay, I extracted data. Okay, I extracted data and correlation values of one bivariate relationship. So if you see the sheet, Moore 2006, okay, he worked on attitude intention. Now this whole Excel sheet is only of one bivariate relationship, attitude, intention. Okay, so you will ask me that on the right side, I see so many bivariate relationships. What do I do? All of these get converted into Excel sheets. So if say you have some 10 bivariate relationships that you can see in the correlation matrix, okay, of this one paper, you're going to have at least that many number of Excel sheets. One Excel sheet that you see on the left side, okay, are values of a correlation from all the papers only for one bivariate relationship, which is attitude and intention. Similarly, a second Excel sheet will be, I'm just speaking on the theory of planned behavior. You might be having your own theories. The second sheet will become, say, subjective norm and intention. The third Excel sheet will be of all papers, all correlation values of perceived behavioral control and purchase intention. Okay, then purchase intention and behavior. So all crisscross, we call them crisscross relationships, impacts that you see will all convert into that many number of Excel sheets. Okay, so that is what will happen over here. So we have extracted data. My Excel sheet is ready. Okay, so my Excel sheet is ready, and now I will go for my analysis. So now from here I'll take you to the software, but before that there are some concepts which you need to know. So yeah, so this is what my Excel sheet looks like for one bivariate relationship. Okay, the data that I have to extract is correlation and sample size. These are the two data that two inputs that I'll give to the software. In case you do not get the correlation value, ANOVA's F, T value, regression coefficient, P value, Fisher's Z alone, all these values can also be put into the Excel sheet as inputs. Okay, but end of the day, all these values will get get converted to correlation and only then be put into the sheet. For example, I remember one YouTube video which I saw, barely 1 minute he had explained correlation. So he said if you have a beta coefficient, to make it nearest to the correlation value, just add or subtract, I think, 0.05. So there are methods of converting these values into correlation. So once you have, even so what I'm trying to say is that not all 200 papers will have correlation value. If there are papers which have an ANOVA, say 2 papers have ANOVA and 3 papers have p values and 4 papers have Fisher's Z and 5 papers have regression coefficients, even those can be put into the Excel sheet and converted into correlation. And finally on this Excel sheet, what you have is correlation values. Okay, so correlation values and sample size. It was very surprising and shocking for me also that just these two values are needed for doing the whole meta-analysis. Just these two values. Okay, so let me start with the actual. Okay, yeah, I need to tell you what is a forest plot. You will be seeing it in the softwares also, but I just need to explain a few components of forest plot. Okay, so let me use a highlighter. These horizontal lines that you see, okay, are actually, giving you the magnitude, okay, of effect size of each study, okay. And just a second, let me erase this. And this diamond that you see is that consolidated weighted effect size of all these 10 papers taken together, summarized, which stands at minus 0.48. Okay. You might also see that in a forest plot, this will come as an output. Okay, you don't have to do anything. This will come as an output. I'm just explaining you how to interpret it. So in the forest plot, you will notice these black squares, somewhere they are huge and somewhere they are very, very minute. Okay, somewhere they are very, very minute. These variations are coming on the basis of the sample size. Okay, so if the sample size of a study is huge, this square will become huge. Okay, if the sample size of the study is small, it'll become very, very minute. Okay, at the same time, these horizontal lines that you see, they are the confidence intervals. So you can see that wherever the studies are huge, okay, so the sample size is huge, uh, you will see that the confidence interval is shorter. So I'll explain it another way. Let me take this as the consolidated effect size, and it is minus 0.48, and it also says there's an upper limit and a lower limit over here. Okay, now what do you mean by an upper limit and lower limit? Let me get back again to practical life. Forget the graphs, just get back to practical life. Suppose any of your sons and daughters come to you and say, ma'am, mama, I've got 48%, or dad, I've got 48% in science. What do you tell him? You don't generally tell him, acha, 48 you've got. Acha, you will always get 48. Last time also you got 48. Next time also you will get 48. All 3 years in future you will be getting 48. You don't say that to him. What do you say? As a parent, what do you say? You have this general line, doesn't matter. You might do better. And sometimes when the paper is tough, it's okay. You might go worse. All those parents who are counseling their kids for the CBSE boards, and their kid stands at 48 right now on pre-board, are using this line. Don't worry, boards is like a lottery. So sometimes you might get 67, sometimes you might get 29 also. Okay, so this is what we are saying. So this very simple example where we say, okay, this person has an effect size of, he can score 48% in science. That doesn't mean that he will always score 48. When another researcher or when another author will take the same 10 papers, not same 10 papers, he might take some other papers and do a meta-analysis of this one bivariate relationship. Again, I'm still on attitude and intention. All these 10 papers are listing correlation values of attitude and intention. So if some other researcher does the same research, this effect size, which has come out in my paper to be minus 0.48, could vary from minus 0.67 to minus 0.29. Right? Similarly, like a child comes to you, say, I got 48%. You say, doesn't matter. You can go good. But how good? Will you ever tell a 48% to a child that you can get 100%? You might say, but I think you're being a little over optimistic. Okay, you would, if you are a data person, you would analyze and tell the upper and lower limit. You're not going to tell a person who's been scoring 20%, no, in the boards you will get 100%. That cannot be the upper limit. So on the basis of calculation, if my effect size is minus 0.48, I will be given by the software an upper limit and a lower limit. Okay, I hope that is clear. On the left side, I have a comical representation of this. So the square which you see is the largest on the left side. Okay, it is pulling the effect size towards it. It is pulling the aggregate effect size towards it. So here comes the concept of weighted effect size. Mind you, this is not just a summarized effect size. It is an average weighted effect size. Having said that, the weights have been assigned on the basis of some parameters. It could be sample size. Larger the sample size of a paper, more weightage will it be given. Again, let me come to a practical example. If these 10 studies are not studies, but they are subjects that we all have done in our 10th standard. I remember physical training. If physical training was somewhere like study number 4. So I remember my parents telling, "Bas pass ho jao, just clear it." Okay, the most heavily weighted subjects were subject number 9, mathematics, subject number 10, sciences, subject number 2, English, and every I think all of us do this. You know, we set a art and craft, study number 6, minimum weightage, minimum, we assign minimum weightage, and all these marks together, the overall score that a child gets, that is this minus 0.48. Still, we will say the child can vary from 67% to 29%. Okay, so this, these, what your studies have said, I have just explained it in a practical example, the relevance of all the values of what we call a forest plot. Forest plot, this forest plot is only and only, I'm reiterating so that you don't get confused. All this process is being done only for one bivariate relationship, attitude, intention, and whole process will have to be repeated again and again if you are doing it for 10 bivariate relationships, which means this whole process you do 10 times. Might be shocking, but true. So let me, I have explained the forest plot. So let me now come to, is there, just let me check, give me a minute. Okay, yes. The correlation values, when I go to the software, you'll see these values. That's why I'm explaining you. You will see a forest plot. You will see this, the Fisher Z value and conversions. Okay. Where the correlation value is more dependent on the sample size, we want to convert it into a standardized unit. We want the effect size being used for correlation, being used through correlation to tell us a standardized unit. Okay, so when I say my effect size, which I found out in the last forest plot, is say minus 0.48, I should say that this is not varying. Okay, it is a fixed, it is a standardized unit. So that is the reason you will see the software will first convert the correlation into a Fisher Z value, okay, and then back to a consolidated correlation, and finally give you the consolidated weighted effect size. Okay, so this is just an explanation. You will see a Fisher Z, and just don't get surprised that when we were taking an input as correlation, how come Fisher Z came into picture? It has come into picture because we want to convert the correlation to a little more standardized portion, and that is why we are doing these conversions. Okay, the next slide. Okay, so this is what it does. So the software will take study number 1, and this comes from the book of Borenstein 2009. Okay, reference Borenstein 2009. So each and every study's correlation is converted into a Fisher Z value. Then an overall Fisher Z summary is taken out, and from the summarized Fisher Z, again, it is converted back to a summarized correlation, and that is when you get your effect size, consolidated average weighted effect size of minus 0.48. Right? This is the process. I'm just telling you the process. You don't have to do it. But the moment you see Fisher Z, you'll say, from where did this value come? We were working on correlations. Okay, we were working on correlations. Okay, these are a few more values that you will see listed. So there will be a variance. Okay, variance has properties that make it useful for some statistical computations. Okay, there will be a standard error. Okay, there will be a confidence level, and there's an upper and lower limit. I hope these terms are clear to you. I am assuming that when you know the concepts of correlation, when you know the concepts of basic bivariate analysis, I hope these concepts are clear. You will see them in the analysis. Why I'm showing you these is because they're going to come in the software. You shouldn't get confused from where they came. This is all that you're about to see. And finally, yeah, I call this slide for the love of calculations. Not everybody has it. I personally don't have it. But for a few of you who want to know how did those values get generated, these are the values. These are all formulas taken from Borenstein's book 2009. And by the way, the book is available as a PDF, a free PDF. Okay, and if need be, even I think Kaushik sir or I could give it to you. Kaushik sir also has Hunter and Smith, if I'm not wrong. So these two books, of course, Borenstein is the easiest. It is the easiest. I've learned from Borenstein. The Borenstein, Hunter and Smith are the two books, and the PDFs are available. If you want to get back into how these calculations manually were done, you can get back. But thanks to the two, thanks to one software and the free Excel macro that I'm about to show, you will not need this. But in case any of you wanted to know this, this is it. And finally, once you've got the value, you have to interpret it. So once you get a p-value of 0.05, you interpret it. Okay, so the method of interpreting an effect size that you've got from all this, those Excel sheets and software, is that a very small effect size. If just give me a minute, I have to place the screens a little left or right here. Yeah, so 0.1 is a small effect size. Okay, 0.3 is a medium effect size, and 0.5 is a large effect size. Effect size of what am I working on? Attitude and its impact on intention from a set of 31 studies from the past 20 years. Okay, this is what is my conclusion, and this is what I'm going to conclude. Says who? Says Cohen. Cohen, the person who actually gave the Cohen-Dees values, and Cohen-Dees interpretation you'll see is more refined because they talk about medicine and there a patient is involved. Cohen says that nothing less than 0.8 is large effect size. So don't try any medication on a patient if it's less than 0.8. That's what Cohen says. So that's about the interpretation. And yeah, D family we are not doing. So now we can quickly go to, I'll just stop sharing this and I'll come to the to my software. Just give me a minute. I shouldn't have stopped sharing. I should have minimized this. Give me a minute. Yeah, so this is the comprehensive meta-analysis software. Now it's visible. Yeah, there's a lag of 3 seconds or so. Yeah, so this is a comprehensive meta-analysis software. A trial version of this is free for somewhere around 10 days if you want to learn how to do calculations on this. If you do not even have this, I have it because I do a lot of meta-analysis papers. I have a paid version, but in case you want to do it on a free, so this is Meta Essentials free macro, and courtesy Kaushik sir and his YouTube videos. I did not know about this. All I knew was that, and there are more. I mean, it's not that this is the only free one. Our software has a package called Meta-4, okay, which can be used free of cost to do a meta-analysis, to do all the calculations that I'm about to tell you in the next 2 days. Okay, so but the only thing is R needs coding, so a little bit of a hand on coding, and you'll be able to do meta-analysis with Meta-4 in R. This that I'm showing you is Meta Essentials. Okay, you can go to Google and download it. Okay, I think the website is erim.something. There's a URL, and you can download the workbooks. Okay, and these workbooks, this workbook that I've opened is of correlation. You have workbooks for calculating Hedges G, which was the D family. You have workbooks to calculate the others family odds risk also, right? So there are many workbooks. The workbook which I have opened over here is the workbook where we will work on correlations. Okay, so this is the analysis part. You could Meta Essentials is one. R is free. Jamovi is free also. Jamovi also is free, and it has. I'm not quite aware of what is the package that is to be used, but Jamovi also helps in meta-analysis, right? So let me start with comprehensive meta-analysis. This is the first software I ever worked with for meta-analysis, and let me tell you how we enter data. So this is an absolutely blank sheet. Okay, this is how it will look when you download it. So I'm starting entering data. Okay, and any questions, please, at 11:15 or 11:10. Okay, I think there are quite a few questions. I will stop at 11:10, but meanwhile, I'll show you the process and I'll show it to you twice. Okay, I'll show it to you twice because no questions in between. Yeah, so insert. You first, I have to make columns. Which columns? If you remember, there was a study size, there was a correlation value, and there was a sample size. That was my input in Excel. That is why how I have saved it in Excel. Now I have to start bringing it to this database. So how do I do it? I go to insert column for study names. Okay, insert column for study names, and automatically there is a column of study names. Here I will be adding my 10 studies or 6 studies or 5 studies or 31 studies. Okay, for which values of which bivariate? Attitude and intention. If I'm doing this whole process only for one bivariate, if you want to do it for another, do the whole process again for all those 31 papers again. Okay, yeah, so this is for study name. We further go to insert column 4 and go to effect size. I'm repeating, insert column 4 effect size. Okay, it will say show all 100 formats. Just go to next. It will say compare two groups, etc. Just go to next, and here you have an option. Here you have an option of correlation, very clearly given. Okay, go to correlation, go to computed effect size, and when you go to it, the software will give you all the inputs that you can put. So if you remember, I told you you can put t-value, you can put Fisher's Z, you can put correlation, you can put p-value. Remember, I told you all those values. Okay, so in this software, what happens is the moment you press the column, it will start taking values. It will itself convert it into correlation. Okay, so you don't have to manually convert the t-value or the p-value into correlation or the Fisher's Z value into correlation. It will do it itself. You just have to input it. But the simplest form of effect size that I'm doing today is correlation and sample size. Okay, so correlation and sample size I will select and I'll go to finish. I'm going a little slow because it's a software, and of course there's a lag time of 3 minutes, which I understand. So I can very well see you. You still can't see the. Now you can see the screen. Okay. So now what has the software done? What has the software done? It has created. Okay. These white columns that you see. These are your input. Okay. These white columns that you see is the input, and these yellow columns that you see is the output. Okay. The yellow columns is the output. Now let me do it for say 5 studies. I'm entering the value. Okay, and you can just see. So suppose the first study was by an author called Raw. Okay, some people also ask me, ma'am, what if we straight away start putting correlation, sample size? No, you can't do that. The software will not allow you putting all this without the study name. So suppose the correlation between what? Attitude, intention was 0.5. Sample size in that paper. These are my papers, by the way. This is secondary data. In meta-analysis and systematic literature review, we do not work on primary data. This is my secondary data, which is becoming an input to calculate effect size. Sample size 300. Okay, there's an effect direction. You just press an auto. Okay, so it'll take, if it's a negative correlation, it'll take it negative. It's a positive, it'll take it positive. So auto means take it as it is. The sign does not matter. Okay, here you have a study of Garner. Okay, and the correlation value is say 0.6. and the sample size is, say, I'm purposely making it a huge sample size to show you something, okay, a concept which comes in the evening, but I'm purposely showing this. Okay, then there's a um, okay, there's a study by Gemmer which says that the correlation of attitude and intention for his context, it could have been mobile phones in, say, Asia. Okay, mobile phones in Asia. So the sample size was somewhere around 400, and okay, auto. The moment you press auto, it gives you results. You can see it's automatically giving you results. Why I explained you the Fisher Z was because you're seeing Fisher Z over here. That is the only purpose. So Fisher Z, standard error, variance. Why I explained that in the slide is because you'll see it here, so don't get confused. Right, hammer was 0.8, sample size was, say, 50. Okay, so these are all papers. Let me put just 5 papers because you're short of time. Okay, and here we go. Okay, this is the correlation of attitude and intention of all the papers that I got. I've done it for 5. You're going to do it for 31. You're going to do it for 31. So you got an automated value. Now you have to go to analyze. You have to go to analyze and go to run analysis. I repeat, you have to go to analyze and you have to go to run analysis. Okay, analyze and go to run analysis. So this is the final table that you've got. So let me use the drawing tool a little. I'll try to use a pen. Not very good at it, but anyways. So this is what is your forest plot. Okay, this is how it looks in the software. Further, this is the yellow line shows analysis. So this is your consolidated average, weighted, mean, whatever you call it, effect size. Okay, so I've done it for 5 papers. You'll get it for some 31 papers, and this is what you have to report. And how do you report it? You have to go back and refer to Cohen. You have to go back and refer to the standards of Cohen. And as per the standards of Cohen, anything above 0.5, he said, is a very high effect size. High effect size for which type of studies? For our family, for social sciences. The same value will be medium if this was a Cohen D value. I repeat, this same value will be medium if it is for Cohen D, because over there he says that anything below 0.8 is medium. But for social sciences, the value that he has given is 0.5, okay, and that too for a high effect size when it comes to social sciences. So I have concluded that from all the papers that were there, all the 200 papers that I have studied from the past 20 years, and I came to 31 papers on which I did a meta-analysis for a bivariate relationship, purchase intention, sorry, attitude and purchase intention. The overall papers show an effect size of 0.5, which is a high impact. So where somebody did a study on mobile, some on automobile, some in India, some in China, I, as Dr. Jaspreet Kaur, has summarized all those studies and said that it's like, you know, getting on the top of your house at a tank and saying, listen, this is it, and come and challenge me. Okay, so all consolidated studies have given me an effect size of 0.501. I would want to tell you one more thing. Just a second, let me close the drawing. Yeah, normal non-drawing mode. Yes, so one more thing which I have to explain you is the allocation of weights. So there's a blue E sort of an icon which you see in the toolbar, and the moment you press it, it gives you the weight. So now just look at it. Now, let me erase all drawings. Okay, now what I want you to look at is that these are the weights assigned by the software to each study. Remember, maths, science, highest weight, physical training, art and craft, minimum weight. Remember that it is the same concept. But here, the assigning of this weight has a basis, that basis of assigning weight we will do in the evening session. Okay, I'll come to something called a fixed and a random model. I'll come to how weights are assigned in a fixed and random model. I will come to two effect size values, one in fixed, one in random model. I will come to how you choose. Which one should you choose? Should you choose the fixed or random? So that we'll come to in the evening session. Right now, what I'm trying to show you is that the if calculation of effect size is not like an normal average mean. No, it assigns weight to each and every study. What I want to show you in this model, remember it's a fixed model, but just remember it for namesake. What I want to show you is that you got to look at you got to look at this weight. Just look at the weight, this weight, 46.36, assigned to Garner's study. Okay, and I'll tell you the reason of assigning of this weight. This high amount of weightage has been given to Garner's study number 2, 46.36, because if you remember when I was entering the weight, Garner's sample size was somewhere around 900. Okay, and this is not something which only pertains to meta-analysis. Many of the concepts come from basic data collection, sample size, correlation techniques, all basics come from there. So even when we are collecting data, and I even in a normal research paper that I do where I have a correlation to be proven between two variables, and I ask the experts, sir, how much weight should it be? As PhD also, you must have gone to your guide and said, how much sample should I take? So what does he say? Does he say take 50 samples? Does he say take the minimum? What does he say? Go for maximum. In a structural equational modeling technique, if you're doing a PhD on that, anything less than, I don't know, I might be exaggerating, but anything less than 500 is criminal according to me. I don't let my scholars take anything less than 500. So every time you go to a guide, see, I mean, research comes from normal life here. I mean, just imagine, let me talk of a study of COVID that I just explained. Will you people be able, if tomorrow I tell you I'm giving you a free vaccine of COVID, will you people come and be ready to take that vaccine if I tell you it has been tried only on 20 people on the world? Will you be able to take it? Will you take it? You'll never take it. But if I tell you, listen, it's been tried on some crores of people in India alone, it is perfect for the Indian body, then you will take it. So higher the sample size, the point I'm trying to drive is higher the sample size, higher the accuracy of data. And this is an assumption for the software to calculate weights given to each and every study. And if you remember, this study 2.43, this study 2.43 hammer study, I had purposely put a sample size of 50. Look at the weightage assigned to it. Look at the weightage assigned to it. Now, the backend calculation of how this weightage has been assigned, the formulas are given in Borenstein's book. The formulas given on my PPT. But if you really want to go further, and why shouldn't you? If any of you are interested, then thanks to Dr. Neeraj Kaushik's Excel sheet. This is his Excel sheet. I made it on Excel after looking at his video. So look at how much in detail he's gone into. First he's converted the R to Fisher. Then there's a sample -3, that is the weight. Then there he's calculated the variance, then the percentage of weight, and then all the calculations, and finally somewhere he reaches at the end to an effect size. So if you really want to do, really want to know, there might be a few of you. Of course, it's not needed, but there might be a few of you who want to learn that. This is the Excel sheet, and it is available on YouTube, Neeraj Kaushik sir's video, and it is not available anywhere else. No other YouTube video, no other. I have gone through this horrendous process of learning meta-analysis for correlation values for social sciences. No other video gives you such an elaborative explanation of how to calculate effect size and what are the back-end calculations which are going on. So this is for you. So I'm just trying to list all the sources of data, all the sources of learning analysis. Okay, so you have a website of comprehensive meta-analysis if you want to learn the CMA. There are videos, free videos for that. There is Kaushik sir's video if you want to learn it on Excel. Forget learning it on a software. On a basic Excel also, if you manually want to calculate it, this is there. If on a automatic macro of Excel you want to calculate it, there is Meta Essentials. This is also a free macro, can be downloaded. And let me show you, this is what, so there are so many sheets. You see there's an input sheet, there's a forest plot. Okay, a subgroup moderator we have not reached, I'll not show it to you today. So we have reached these two sheets. One is the input. Okay, so just look at the input. So there's a study name here. Of course it is AABB, whatever. You could change the name. So it's almost like it's like working on an Excel. I can change it to raw. Okay, correlation value 0.98 between what? Attitude intention. This whole sheet is only for attitude intention. Number of subjects, which is the sample size. There are two more columns which say which is the study sufficient. So you just press a yes. And subgroup moderator we are not talking about. So these are the columns. They are absolutely same as we did in the CMA. Absolutely same. Okay. After you have just input these columns, okay, you just have to input this data. And in CMA you still have to go to analyze and then run analysis. Here you don't even have to do that. I mean, such a good free piece of macro, you don't have to do even that. All you have to do is just go to forest plot sheet. Your analysis will be done automatically. You don't even have to in CMA at least you have to go to analyze and then this thing. Here you don't even have to do that. So you, sorry, I don't know why I by mistake stopped share screen. Sorry. Right. So here you are, and so yeah, let me talk about the values. So this is your forest plot. Okay, let me use the pen. So this is your forest plot. Okay, this is your forest plot. Okay, this value that you see, the green one, is your consolidated average weighted effect size. Which effect size? R family correlation effect size. Effect size of how many studies? Over here it's 12. In your research it will be 31. Correlation values of 31 studies, of which bivariate I am still doing attitude purchasing. Okay, and of course this I've explained to you. These confidence intervals I've explained to you. So let me remove this, erase all drawings. Okay, the moment you click on the, just give me a minute. Okay, the moment you click on this green little ball which is made, it shows combined effect size. Yeah, it shows combined effect size 0.79. Okay, where do you see it around in the data? I'll show you. You see it over here. This is where you see it. So this is the combined effect size 0.79. Now interpretation is same. Interpretation doesn't change with softwares. Interpretation is same as was to the author, which was Cohen, who said that anything above 0.5 is high. So even according to this research done on this macro of some other studies, which is somewhere around 12 studies, the resultant is that the effect size of attitude to intention is high. High at how much? 0.79. Okay, it has the lower limit. Okay, remember that child who was getting 48% and you told him you can get either 67 or 23. So this is the upper limit, lower limit. Okay, and yeah, there is the next concept that is coming up in the afternoon is the drop down over here, which is a fixed model and a random model, just for the heck of it. So when I bring the drop down to a fixed model, if you see, my effect size has changed See, it's become 0.88. I just brought, in meta-analysis model, I brought the model from random to fixed, and it changed to 0.88. Let me again play with it. I'm just making a base of the afternoon session actually. So let me bring it to random, and my effect size has changed. So now, after the calculation of effect size, whether it's the CMA, whether it's the meta essentials, whether it is R, whether it's Jamovi, I will get two types of effect size. One will be random, one will be fixed. Now starts the dilemma. Which one should I take? Should I take random? Should I take fixed? That I will explain in the afternoon session. Now, if this has been explained on all softwares that I have explained, I want to go now to the paper. So this, your result has come, interpretation has been done. Now let me go to the paper. Where is it? Just give me a minute. I just want to open the paper and show you how you report these. Just give me 1 minute. Many windows open. PPT. Just give me 1 minute. Just open the paper. There it went. Yes. Yeah. I'm just sharing the screen. This is the paper. I just showed it to you in the last session also. Remember, I was telling you about PRISMA. So now we have crossed the stage of PRISMA. Okay, and we have come to effect size reporting. So let me take you there. Let me take you there. This was PRISMA. Okay, now this is the first table which you have to construct, and it says random effect taken. Why taken? I'll tell you in the afternoon session. Don't get confused with that. But here you go. So all that I've done is just for this. That's it. I've just reached here. I've still not done Q and I square. That will, the moment we say fixed and random, Q and I, all these will come together in the afternoon session. But you will be able to report this one row, mind you, only one row, because all this has been done only and only for attitude intention. And then for how many papers? The K says how many papers. K means how many papers. So he has done it for 19 papers. Okay. What was his consolidated effect size for attitude and intention for these 19 papers? It was 0.61. What was the upper limit and lower limit of this score of this effect size? 0.54 to 0.68. Which bivariate relationship did he study in these 19 papers? Attitude and intention. Attitude and intention. What was the total sample size? When I say total sample size, if there are 19 papers, some papers must be 200, in some papers it must be 300, in some papers it must be 50, 200,000. The total sample size is what we are trying to show here. Okay, so this is the way we report it. But not only the tabular form, I would like to show you how you report it in the theoretical way also. It's not just that you leave the tables and then you see over here the written part. You can take a minute to read it. Okay, so it says table 1 summarizes. Obviously the whole task of systematic literature review and meta-analysis is summarization. The random effect correlation. I'll tell you what is random and fixed and when to choose it, how to choose it. Between theory of planned behavior variables, I had shown you in the slide, attitude, subjective norm, PBC, if impacting intention. Right from the beginning, I've been working on that model, and I'll be working on the model till the end of the session only. So I've taken up one research problem so that you can relate to it. So attitude has the strongest association with intention, which is 0.61. followed by PBC, which is 0.46, followed by SN, which is 0.35. So of all the three bivariate relationships which impact intention, attitude has been found out to be the strongest. And mind you, this is not a consolidation of barely 500 primary data samples. This is a consolidation. Just see, this is a consolidation. Look here in the table. It is a consolidation. It's a consolidation of some 6,117 samples taken all over the world from the past 20 years of study. Okay, so you can imagine. Now I hope you understand why that PRISMA part was very important. Now I hope you understand why so much of time and energy he's given in the paper to explain what he included and what he excluded. Because his analysis will be on the basis of what he includes and what he excludes. Similarly for primary data analysis. And it's nothing new. Even in primary data analysis, when I say 500 samples, when I say fashion students from Pearl Academy, I remember a paper being rejected. He said, why Pearl Academy and why only fashion students? He rejected my paper. So even over there, we have to justify from where did the sample come? What were the demographics? Similarly, here, because we are not working with primary samples, it's secondary data, justify. From where did it come? What did it consist? And then come to this value. So I'm assuming that you will be able to do other correlations also. Okay, so this is where we have reached in the table, in the paper. So I'll take you through this whole paper by tomorrow. I'm going step by step. And this is where we have reached in the paper. By evening, after the 2-hour session on fixed, random, Q, I squared, tau, we will be able to complete this whole thing. Sorry, I'll only mark one. I'll only mark one row because all this has only been done for attitude intention as of now. So by evening, you will be able to reach one row, and then as per your motivation, the number of bivariate relationships you have taken, that many Excel sheets, that many meta-analysis, that many results. Okay, and even if you see the key, so N is the number of participants, K is the number of effect sizes included in the analysis, which means number of effect size. So what happens is, if you, when I showed you the forest plot, I told you that what happens is that the software gives an effect size to each study. Okay, so effect sizes of 19 studies taken together, summarized, weighted, averaged, come out to be 0.61. So that is the total calculation, interpretation, explanation of so-called R family effect size. The same process can be done for D family. The same process can be done for odds ratio, risk ratio, so on and so forth. Okay, so I'm exactly on time. Yes, 1:10, and now I think we can open the house for questions, sir. So I'll just share the PPT now. Yeah. So I hope it is visible. Yeah, it is. Yes, I can see it is. Okay. So I'll just start. So these this 1.5 hour session which we are having will be on what is heterogeneity. Okay, it will be on what is fixed and random model. Right, I'm just, give me 1 minute, I'm making it full screen, a slideshow, sorry. Yeah, so before I explain what is fixed and random model, I would like to explain what is heterogeneity. Okay, and for that I would like to quote this example, which is very popularly quoted by medical sciences also. In one of the videos that I was going through, I saw that, they were saying that your collective study, again, I'm coming back to those, we are still on those 31 studies which we have taken for meta-analysis. They were explaining that these collective studies should not be apples and oranges. So that is the best way I could understand the concept of heterogeneity, and that's what I am explaining. That see, we have taken out an effect size, and initially when I started studying, I said, okay, now the effect size is out and I'm finished with my meta-analysis. I was quite wrong. It is not only finding out a consolidated weighted average effect size, it is also about explaining the pattern of your studies. So heterogeneity is talking about explaining the pattern of your studies. Are they heterogeneous? Are they homogeneous? If they are heterogeneous, how heterogeneous they are, so on and so forth. Now, statistical heterogeneity is inevitable. So Higgins 2003, 2005, generally in this context, we see most of the work done by Higgins. He says that it's not wrong to have heterogeneity in data. So, the moment I introduce these concepts in the workshop, people get very, I mean, probably, more than understanding, what happens is, as researchers, we want to reach at the data. What will be the outcome? Will we be able to interpret? Okay, is it wrong if it is heterogeneous? So that is the reason the first line that I've put is that statistical heterogeneity is inevitable. But at the same time, ideally, why we are, checking a heterogeneity is because we don't want apples and oranges together. Because when apple is put into an orange, the type of output that you get is what is shown in the slide. So this is genuinely not eatable. Okay, a very high amount of heterogeneity could mean that the studies have nothing in common. Okay, so ideally, in an ideal situation, yes, we don't want that, because if I am working on attitude and intention, and I'm working on attitude of consumers and intention of consumers, all my studies should be speaking about that. So some amount of homogeneity I do want in my data. But in case there is heterogeneity, there is nothing to worry. Okay, we are supposed to plainly be reporting the heterogeneity. Okay, and before I go forward and you people get worried about this one new dimension, oh my god, we'll have to justify it. And in primary data, maybe some people, some not so very ethical researchers believe in manipulation. But in secondary data, how are you going to manipulate? It's a published report which says attitude and intention are at 0.3, and you're naming the author. You cannot manipulate. Whatever results come, just present them as it is. Number one. Number two, if there is heterogeneity, quote Higgins 2003, quote Borenstein 2011, and say that heterogeneity is absolutely fine, or heterogeneity has nothing wrong to do in data. So all you have to say is that the data has heterogeneity, says Higgins 2003 or Borenstein 2011. That's it, period. You don't need to justify it. I'm going to show you that same sample paper that I've been showing you since morning, and you'll not believe it's a published it's a published paper from a university, and it shows heterogeneity values of 90, 98, which is very huge percentage. Doesn't matter. So the first thing you have to take out of your mind before understanding this concept is that heterogeneity is not bad. It is a pattern. You are describing a pattern. You will describe it honestly as it is. You will describe the pattern as it is, and you will not try to defend yourself unnecessarily. So go with an open mind when you are putting your data for heterogeneity. The difference that comes in the data, okay, could be because of a few reasons, and that is when we come to a fixed and random model. Okay, so that is when, so what we are going to do is, In both the software and the Excel micro that you saw, there was a fixed and random model, and the effect sizes were different. Which one to take? That justification is about to start now. Okay, and that is what is the reason this topic is being undertaken. So an ideal data, your paper might not be ideal, and you just have to, as I said, just report what you have to. But an ideal data is not absolutely homogeneous. So we don't want to have all red apples, and it is not absolutely heterogeneous, which means I don't want to have apples and oranges and bananas all piled up in my 31 reports. Okay, so an ideal data is heterogeneous to the extent that we have all apples, which means all 31 reports are similar. There could be a green apple and a yellow or a green, yellow, or red, any one of them. Okay, small sizes, big sizes, something very similar to what I explained in the morning with the concept of horses. Okay, so your papers are nothing but apples and horses. They could be big, small, fat, thin, high in sample, low in sample, so on and so forth. Now, we have come through a forest plot, and now let me describe how we see a pattern of heterogeneity. So how do we explain if there is heterogeneity or not? So the first method of explanation, or the first basic judgment that we do, is what we call an eyeball test, and that is done with the forest plot. So my forest plot is the first parameter that I evaluate, and if you see this forest plot, so you see these studies to the right of the mean, mean as in the consolidated effect size. Okay, consolidated effect size. Then you see these studies to the left. Again, you see these studies to the right. Again, you see these studies to the left. So what you can see is that they are all not falling into a line. Number one, they are not close to the mean. Okay, they have very varied effect size. Okay, so I told you that the software calculates an effect size for each of the studies. So each of the study has an effect size. Okay, and that effect size is not matching. If I say in layman language, the effect size is not matching the mean. Oh, sorry, it's not matching the mean. So that is a very big problem for me. Okay, or not a problem, actually it's a pattern. It's not a problem, it's a pattern that my studies are haywire. I mean, they are left and right, and they are not next to the mean. Now with the type of forest plot that I see, different studies will have different forest plots. Each and every bivariate relationship will have a different forest plot. But as far as I can see the forest plot over here, I can see from the eyeball test that this is an absolutely heterogeneous data. Okay, I don't see the studies falling in line with the mean. Okay, the mean here I'm referring to is the consolidated weighted effect size. Okay, shown by the green ball. So that's the first method in which we say whether the data is heterogeneous or not. I'm repeating again, we are not saying whether our data is correct or not. We are not questioning on whether our data studies collected is right or wrong, or our meta-analysis is right or wrong. No, we are describing a pattern. We are going to be fair as researchers. We have been fair while collecting data. We have explained to the editor through PRISMA, these are my studies. We are going to be fair in reporting it. If it's a heterogeneity of 98%, so be it. We are going to be fair in reporting it. So through the eyeball test, I feel this seems to be quite a heterogeneous data. So that's the first method. That's not enough. It's not enough. So we come to a second value, and I'll be explaining this when I go to the software also. You'll be seeing this. The second value is the Q value. Okay, a Q value is nothing but a chi-square test. I hope you all are aware that chi-square test is a bivariate test of associations, okay, and it is judged by something called a p-value, okay, and in social sciences we say that a p-value above 0.05 means there is no variance, and if the p-value is below 0.05, which means there's variance. Now just replace the word variance with heterogeneity and apply the same principles to judge heterogeneity. So if you are doing a q-value test and your q value comes out to be less than 0.1, some people take 0.1, some people take 0.05, depending on how you justify true references, your confidence interval. So that is up to you, how you justify. So if I'm taking a 0.1 or if I'm taking a 0.05, anything, if the p-value, the q value and the p-value of the q statistics is lesser than 0.05, which means your data is heterogeneous. In case the p-value of this q statistics is above 0.05, which means the data is homogeneous. Okay, so it's the same concept. As I said, a few concepts come. It's a basic concept of p-value, significance of variance and no variance between the two data set. Okay, where you're finding an association. So the same concept has led to notifying whether it is heterogeneous or not heterogeneous. Further, we could have stopped here actually, because a q value told us whether it is heterogeneous or not heterogeneous, and an eyeball test already told us that it's heterogeneous, so we could have finished here. But there was a problem in this value. The value depends on number of studies. That is the first problem. Okay, so in meta-analysis, it could be possible that for one bivariate relationship, I get merely 10 studies. Okay, and the moment I get some 200 studies, this value will start changing. So that's not good for my data. Okay, so based on topic, I could get 20 or 200 papers. So this variation is not good. That is the first problem. The second problem came as defined by people working in the medical stream, was that when they tried to find the effect, the heterogeneity of data among studies. Say, for example, I'm coming back to the very relevant example over here, the COVID vaccine coming to India, the Pfizer COVID vaccine coming to India. That is my problem. And I'm doing a study, a heterogeneity study, and I see, okay, 200 studies I take, and the effect size comes out to be some 0.9. So should I bring the vaccine? No, I should check the variation. I should check the variation. Now, what will the Q value do? Like a P value, it's just going to tell you whether there's variation or not. So sometimes in a medical study, what used to happen is in the minutest of variation, minutest, I mean, even if it is like 0.1, 0.000001, it still showed a significant P value. So even when the heterogeneity in the studies is negligible, absolutely negligible, 1%, 2%, the P value will come significant, because the purpose of the P value is to check whether there is heterogeneity or not. So even at 1% heterogeneity, it's going to say it's heterogeneous. And that is where you go wrong in your interpretation of results. So this vaccine that we are talking about, if there is a 1% heterogeneity reported, it gives an alarm. In medical sciences, as I said, this concept comes from medical sciences, and there it's a matter of a human's life. So they are more careful. So even if there's 1% heterogeneity, it's an alarm. I mean, how come the studies that we have studied are not talking about what we are studying, or why are they heterogeneous? So that is the reason. Even the last line that I've got, and I've got this from Cochrane. So even clinically unimportant data, clinically unimportant significances heterogeneities were reported by this method, because it's a method of reporting yes or no. So again, the problem that came even in effect size, I want the magnitude. I want the magnitude of my heterogeneity. So to get the magnitude, to go further and see the percentage of heterogeneity, we have another value, and of course the calculations, the formula are given over here. The formula have been taken from Borenstein 2009-2011 book. These formulas are also, the calculation of Q, I squared, tau are also shown in Kaushik sir's Excel sheet that I showed you, and in the video, those calculations are also shown. So even this heterogeneity, for those of you who want to do it, you can calculate it manually, one by one, step by step on an Excel also. Okay, and the same Excel sheet that I showed you in the effect size session, I'll show it to you again. It has calculated, sir has calculated the Q value there, Q, I, tau, everything. So next we had to move ahead. So we went to a value called I square. Okay, so not we, of course, the fathers of meta-analysis, Higgins and Thompson, they said that we want a quantification, because in medical studies, even a not so very significant heterogeneity got reported, and thus there came a value to report the percentage of heterogeneity, which is called the I square statistics. Okay, as per Higgins, there is a benchmark for the I statistics, and the benchmark is that if the heterogeneity is up to 25%, it is low. If it is up to 50%, it's moderate. If it's up to 75% or above, it is substantial heterogeneity. But having seen this, I am reiterating the point. There are research papers which I'm going to show you which are reporting 90-92% heterogeneity. And it's not that you are reporting it, it's that secondary data collected from 200 papers or those 31 consolidated studies are showing it. So past research is showing it, you can't do anything about it. You're not wrong. Okay, so the only point you might have gone wrong is the PRISMA point, where you were including studies, excluding study. This is no time to think that I've gone wrong. The time to think and check everything is during your collection of data, inclusion, exclusion, and building of the PRISMA. So I square was not sensitive to number of studies, unlike Q. So that was one positive point. Second thing, it also gave us a percentage. It gave us a value, so we could report this value. And by the way, we do report the I square percentage in our studies. But there was still a problem that this value depends a lot on precision. So variance between variance, total variance. So you can see in the formula too. So this was too dependent on the precision of the included studies. So to remove that bias, there's another value that we calculate, which is tau square. Now, when I say eyeball and then Q and then I square and then tau square, it doesn't mean that I have discarded eyeball and come to Q, now discarded Q and come to I, discarded I square and come to tau. That's not what I mean. We calculate all these four values and we report all these four values. Okay, so it's not that I'm just explaining to you as per Cochrane's database of papers that I read. I'm just explaining to you why there was a need of four values rather than just an eyeball test. I'm just explaining you that. So tau square is insensitive to the number of studies. So that problem of Q test is gone. It is also insensitive to precision. So that problem Y square is gone, and this is a perfect method. It's a variance of true effect size. Okay, so if I could put it very simply, of course the formulas are there. I saw in one of the videos it was put very simply. I'll explain what is tau. So let me come to study number 1. Okay, the study number 1 is, deviating from the so-called mean to this much extent. Okay, to this extent. Okay, study number 2 is deviating to this much extent. Okay, I'm just giving you an example in a very simple language and explaining what is this. This study is deviating to this much extent. Okay, another study is deviating to this much. So all these deviations taken together for all studies will give you your tau square value. Okay, so that is the most simple method of putting it. Okay, so that is what is the tau. There are no benchmarks for tau. Okay, so there's no benchmark. There is a benchmark for Q, which means that if the value is more than 0.05 or 0.1, whatever reference you are taking, then there is homogeneity. If the value is less than 0.05 or less than 0.1, there is heterogeneity. There are benchmarks for I square, wherein 25% low, 50% moderate, 75 above sustainable, which is high. But as far as tau square is concerned, from what I have studied from books, the tau square should not be 0. So that is the only benchmark that you have to check. So in case, and when I take you to the study, and when I take you to the research paper, you will see that all these things are related. So if you get a Q value which is significant, your I square will be 50%. You will not get an I square of 90% and a Q value not significant. It cannot happen that way. How can my heterogeneity be 90% if the Q statistics did not even report heterogeneity? Okay, through p value. So these all will go in in association. Now, one last conceptual thing which is left before we go to the software, which is fixed and random model. Okay, so I again I'm bringing in a little bit of comic relief. It seems to be quite a technical topic, so let me explain this in a nowadays I see on Amazon also there are quite a few courtroom dramas. So I took up this theme from there. So these two lawyers that you see in the shadows are one is Mr. Fixed and the lady is Miss Random. Okay, and the judge that you see, due apologies for that comic, but that's a researcher, and he has to decide. Poor guy, although he has to decide whether I should be taking up the effect size of a fixed model or a random model. Okay, so we are entering into a courtroom drama where the researcher has to decide, and these two lawyers are prosecution and defense, and they are giving their own arguments for picking up a particular effect size, be it fixed or random. So let's come to the arguments they are giving. So Mr. Fixed Effect says that we assume that all studies have the same true effect size. Now, you will have to understand what's a true effect size, and for that, I'll have to take you to this diagram. I'll come back to the argument, but I'll explain this through this figure. See, I'll let me go back to my forest plot. See, it is very evident that this is the average mean effect size, okay, or the true effect size. And the software does calculate the true effect size of each of the studies, which is this, and this, and this. And you also see that all these effect size are varying from the mean. Okay, you also see they are varying from the mean. They are different from the mean. Now, Mr. Fix says that these variations from the mean are due to chance, or what we call sampling error. And Miss Random is debating that no, these are not because of chance. This is because of something. That is the whole debate that we are getting into. Okay, I'll repeat. There are deviations. So what you see is the true effect size. The blue dots, so they are the true effect size. And the software calculates the true effect size for each and every study and then consolidates it into a final effect size, which is the green ball. So when the software is calculating effect size for each study, okay, you see a variation, you see a deviation from the mean. Mr. Fix says this deviation is by chance or because of sampling error. Miss Random says no, it is not by chance. There are some other solid reasons for this variation. Okay, so now let me go back to the argument. I hope you know what is the case now. I mean, I'm just trying to explain you that what is the courtroom drama all about. So this starts a courtroom drama, and the fixed Mr. Fix says that assumes one true effect size for all studies. So he says that these variations that you see, okay, these variations that you see are because of chance. So what are you trying to say? You're trying to ignore the variations. You're trying to ignore the variations, and you're saying no. There is one true effect size, and all studies are having the same true effect size. This is what you're saying. This is what you're assuming. So there's nothing actually called a fixed or random model. It's just the assumptions. It's just the assumptions that, and as a researcher, you have to decide what are going to be your assumptions so that you can decide which effect size to take. So the fixed effect says that all these effect size deviations that I've shown you in the forest plot are just because of chance, just because of sampling error, and all these studies are actually having the same true effect size as is the consolidated one. And thus fixed effect model assumes that all these studies effect size will lie in the line of the consolidated effect size. Okay, now let us hear what Miss Random, and then they're going to give arguments also why they think so. So just hear out those arguments. At the same time, Miss Random says no. She says there is only one true effect size, okay, and which is of course the consolidated effect size, and all these deviations are genuinely because of some huge reasons, okay, and she lists those reasons also. Let me highlight them. She says it is not only because of the sample size, it is because of type of sample, treatment done, design of research taken. There could be further location of the study, okay, the technique of research used, okay. So Miss Random says that these deviations are genuine, and all the studies do not have the same effect size. Rather, they independently have their own effect sizes. So just let's look at the graph of the random effect model. What does Miss Random say? She says, okay, there is something called a consolidated effect size, but there is a deviation, and this deviated effect size is the actual true effect size, and it is not similar to this one, the consolidated one. It's not similar to the, sorry, it's not similar to the consolidated one. They are different. All of them have their own effect sizes, and these deviations are actual. They are real. It is not because of chance. You cannot assume that all of them are falling in line like the fixed model. Okay, so these are the assumptions of Miss Random. Okay, so I hope you've understood the problem they are quarreling about. They say that these deviations are real or not real. That is what the problem is. Now, in case of course, the researcher is not satisfied with this. So the researcher wants to hear more. He wants to hear that on what basis are you assuming this? So the fixed effect assumes that all studies along with their effect size stem from a homogeneous population. Okay, so they are assuming that the data is homogeneous. At the same time, Miss Random says these effect sizes are originating from heterogeneous data. Says who? Says Borenstein. Okay. Similarly, Mr. Fix says that these variations that are coming, basically he's saying I'm not ready to take these variations. I don't accept these variations. So he says these are nothing but sampling errors. And he assumes that if the sample size is very high, these deviations will go away and we will get a graph like, just a second, we will get a graph like this. Okay, the fixed model graph. Okay, so what he's trying to say is that these deviations are because of sample size. Once we increase the sample size to a very high level, these deviations will go and the effect size will become equal to the each study's effect size will become equal to the consolidated effect size that we have calculated. Okay. Miss Random does not agree. She says these deviations are not only because of sampling error. They are not only because of sampling. They are because of research method, treatment, type of population, location, the different scale used. The different scale used. I'm still on attitude and intention. Maybe those 31 studies have used 31 different types of scales. So this variation is because of it, and it is true. Now, this is the debate between the two. Okay, and it's not new. I mean, I remember when I was doing a paper on structural equational modeling. So I remember the model, so-called model, which always runs in an FTP, does not run when you actually do it. So it was not running, and I really went to a consultant and I asked him. I said, I've got all the data, and it is genuine data, and it's a very good model, and I wanted to run. So what do I do? And I'm caught. I mean, it was a dissertation of a student. She was ending her dissertation with me, and finally, after doing, and a good student, so finally after doing all that, her model didn't run, and she was almost in tears. She said, "What do I do now?" So I remember the expert telling me that Jaspreet, try and take this data which she has collected of 200 people to somewhere around 600 people. Although it was a Herculean task, but we did it. We did it, and the model ran, well. So, and I think, I mean, of course, Kaushik sir will correct me. I think that can be done. I mean, it's not something which is unethical. So, increase the number of sample, increase your precision, okay, and so that is exactly what the fixed model says. It says these deviations will finish the moment you increase the sample size. But Random says no, these deviations are real and they are not because of sample, but some other factors. Now, in this debate, and because of this debate, there comes a criteria of within and between study variance. Okay, so now this sample size variance, which Mr. Fixed is talking about, he names it within study variance. But Miss Random says, okay, I take your point. Fine. I take your point that some variation is because of sampling. So I accept the within study variance, but I will also say that there are some other sources of variance like research method, treatment, type of population, and I want to take them into consideration, and I will name them between studies variance. Okay, so where an effect size takes into consideration only and only the within study variance, the random model takes into consideration the within and between study variance. And this between study variance, a special case taken up in random effect, this is what changes the effect size value. And this is what forms the tau. So when they say tau shouldn't be 0, okay, which means there is no variance. Which variance? Between study variance. Okay, so the I squares and taus, they are all measuring the between study variance. Okay, we will also come to this when we do okay, because over there in regression statistics and output, we actually show that variance, the sampling variance vis-a-vis the bit. So we differentiate between within and between, and within the between, from the between, this much is justified by a variable, thus it's an effective moderator. So we'll do that tomorrow. So that's about simple and random. Let me see if I'm left with a slide, or else we could we could go to the software. Okay, just a minute, and to drop this off. Okay. Okay, so this is the explanation, the formulas. Okay, and if you see on the random, there is a tau, an extra value calculated in the formula which was not there with the fixed model. Okay, and of course, for the love of formula, these are the formulas for calculation, and they've been taken by Borenstein, and this is for the fixed model. So if you're about to calculate the effect size through a fixed model assumption, okay, these are assumptions. So if you're going to calculate the effect size with a fixed model assumption, these are the formulae. If you are about to calculate the effect size from a random effect model perception or an assumption, these will be the formula. Okay, and if you want to see in detail these formulas, even an example, a real-time example has been given in the Borenstein's book. So he's actually picked up a pseudo data and done all these calculations and shown it and interpreted it also. Okay, so Borenstein's book is very simple to understand if you can get a hold on it. So actual, real-time examples, like I remember in maths also, whenever we used to have formulas, so there was always this this problem, real-time problem given, the age of the daughter is this much, and after 10 years, the father and daughter will become this much, so how much is how much? So all those real-time problems are given in Borenstein. Yeah, so that's about the presentation. And now let me go to the first thing first. This is the sheet. Let me wait for a minute, there's a lag. Yeah, so this is the sheet. Again, this is Kaushik sir's sheet. I made it from the YouTube video that he had, and if you see it, let me come to that. Yeah, so yeah, so he has calculated the Q, the tau. Okay, I will now come to the weights. I'll go to the, I think I'll be a little more comfortable in the CMS software to explain to you how the assignment of weights given to each study change when there is a tau value. Okay, so the final assignment of weights really changes because the tau gets added in a random model. Okay. Yeah, so I'll just show you here. So if this is the W weight for fixed, okay, just look at the values. Okay, for weight of fixed, weight assigned to each study in a assumption of fixed model, and these are the weights which are assigned to each of those same studies when you're assuming a fixed model. The difference is the formula, where here we have a tau square. Okay, so the T2 is tau square. Okay, and how did we calculate the tau square? That Kaushikar has very well given over here. So this value of tau square has been added to the weights of random effect, and that is the reason the weights allocated to each of them, each of the studies has suddenly changed in the random model, and because the weights have changed, finally the effect size has changed. Okay, so at least now you understand that this effect size of 0.35 in fixed and this effect size of 0.48 in random, why that difference has come. Of course, I'm not going to do many calculations, but the difference has come because the weight assigned to each of the study has been done differently. Whereas in the fixed model, when I was assigning weights, I did not take tau. In the random model, when I was assigning weights, I did take tau. Okay, and tau is between study variance. It is the variance which Miss Random was very adamantly talking about and said, no, you have to take it. So yeah, we have taken it. Okay, so so that's one thing. Now can we come to, I'll go to CMA, then I'll go to Meta Essentials, and then I'll go to the papers. Okay, so you should know how to report this also. And let's see in one or two papers, if they have taken a random model, what justification have they given. So because by the way, heterogeneity is not a justification to take a fixed or random. Okay, so I read a lot of material on this, and I quote Higgins 2005, who says that heterogeneity is not only the criteria to choose a random model. You yourself as a researcher make a judgment that there could be a variation in my data because of location, because of studies, because of this, that, and then you assume a random model. So I'm again quoting Higgins 2005, where a few authors, and there's a debate on this. I mean, I really can't say who's right, but there's a debate over this, where some books say that, okay, because a data is highly heterogeneous, above 50%, you should go for a random. There are a few authors who say that heterogeneity is not the basis of selecting a fixed or random model, rather your own judgment of between studies error, okay, the research design, etc., should be the basis of you selecting random or fixed. So we'll just go to 2 or 3 papers and see how those people have defended it. Okay, so let's see, because end of the day we have to write papers, so let's see how they have defended it, right? Or what references are they using. Okay, so according to me, I mean, I'm going by Higgins 2005. He says heterogeneity is not the only method of defending of going for a random model. Okay, so now where you see a fixed or random, on the bottom left side you have something called fixed, okay, and which is by default. So if you remember, we were here, we had gone to analyze, and we had calculated the consolidated weighted effect size of some 6 studies. I also told you that as per what Mr. Fixed was adamant on, he said that the papers which have a higher sample size, this had a sample size of 900, will be given more weightage because they're assumed to be more precise. And he also said that the weightage given to all these 5 studies, will be on the basis of sample size period. He does not, Mr. Fix doesn't consider any other factor. Okay, so he only and only considers the sample size as a basis for giving weights. That is the reason study number 2 with 900 sample size has been given 46% weightage, whereas this poor study of study number 4, where the sample size was barely 50, has been given 2.43 weightage. So Mr. Fixed has clear fundamentals. All this variation is because of sample size. So more the sample size, more the weightage. It's very simple. But just give me a minute. The random is a little different. Okay, so the random is, sorry, is a little different. And when you go on the just on the left bottom corner, you see something called random. Okay, you just have to press it, and now it will show you the consolidated effect size with an assumption of a random model. And just have a look at the weights. Miss Random has not been biased towards sample size. Rather, she has given the weights to each of these 5 studies on the basis of course, she has taken the within study error, which is the sampling error. Not that she's not taken that into consideration. Definitely she's taken, but she's also taken the between study error. Now, please don't ask me, how did she come to know the between study error? I've already told you there are values like I square and tau, which are calculated, and thus she knows that there is a tau, and thus there is a difference in weights, and thus there is a between study error, and thus these weights have been assigned. Okay, so that's about this. You also have an option of showing both the models. Just give me 1 minute. Drawings, yes. Okay. There's also an option of showing both the models. So these are both the models, right? So a very minor, in this case, it's if you see the difference between fixed and random, it's very minor. But sometimes, it's huge. So the Meta Essential sheets that I showed you, sometimes, it's 0.7, 0.8, sometimes it's even more huge. Right, and this is the assignment of weights on the basis of only and only sample. And this is the assignment of weights on the basis of not only sampling error, which is called within study, but also between study. What is between study? Research method, location, sampling, population, everything might have varied, an assumption which Miss Random took, and thus assigned different weights to the 5 studies. Okay, and this is the forest plot, and this is supposed to be your fixed, and this is supposed to be your random effect size. Okay, I hope this concept is clear. We are not yet done because the heterogeneity values have not, because this is just a representation of 4 types of this is just a representation of 4 types of models. Now, which one do you decide on? That is absolutely up to you. But in case you're listening to an author who says that heterogeneity is a parameter, so we should know the heterogeneity values also to decide. So I go to analyze again. Sorry, I go to next table. Okay, just go to next table, and here comes the heterogeneity value. First, let me explain to you what are the 2 rows. So let me first go to fixed. So this is the number of studies, which was 5. Point estimate over here means the consolidated effect size for fixed, assuming fixed model, which is 0.501. Lower limit, upper limit, again, that poor student who got 48% and his father said you can either get 67 or 23. The p value, which means significance. The q value is not that important. What is important is the q values p, okay, or the significance, which is 0.000, which is absolutely significant. So if I go to the interpretation that I told you on the slide, so if a p value is less than 0.05, your data is heterogeneous. And I told you the data will always support it. So 94% heterogeneity. So p-value tells you, a significant p-value tells you that your data is heterogeneous. Your I-square tells you the actual quantity of heterogeneity, which is 94.644, and the tau square is not 0. So definitely this is a heterogeneous data. So if any of you go by authors who say that random model assumes heterogeneity, so we should take it. So you could go for this. I have to use the pen again. Sorry. You should go for this value.
And if you don't go by the authors who say that there is heterogeneity, you go by those authors who say that you know from where your data came, you know from where those 31 studies came. So if you really, really feel that they are weighed, what is the harm in going for a random straight away? When you know your studies come from all over the world, all over from different continents, one particular scale of attitude. The statements vary in all the papers. There are different scales for attitude to be measured in each of the papers. If so much can be explained theoretically, you could straight away go for a random model. Because the moment you say my scales are different, the moment you say my population is different, you are justifying the presence of the between study error, which is an assumption only in random model, right? So yeah, so that's about deciding on it. And now what do? We just a second, I think we should go to okay. And also you can go back the moment you press next table again, it will show you the graph. Okay, and as I said, even if I come to an eyeball test, just look at if this is my consolidated effect size. You can see this study towards the left, and this towards the right, and this next to the mean, and this a little to the right. So they are left and right. So even in the eyeball test, they fail on homogeneity. They are heterogeneous. Okay, and the variation, of course, is shown by tau not being 0. Right. So that's about fixed and random. Now let me go to the Excel sheet. Okay, the Meta Essentials Excel sheet. So this was about the CMA, which is of course a paid software. So many are not interested in it. So this is my free macro. I told you I input all the data over here. I input all the data over here. The data needed to find out effect size, whether it is random or whether it is a fixed model, is actually nothing but the correlation and sample size. So all this concept that I've told you about a fixed and random, this has also all these values that you saw in CMA, you know, the weightage which was given, it has all come from a common input sheet over there also, over here also. So it's not that I gave the software a different input sheet to calculate fixed model and a different input sheet to calculate the random model. The input sheet remains same based on formula and the weights assigned to each study. Okay, the software gives us two values. So here in the model you have something called a drop down. Okay, so if you go to fixed, okay, what is the assumption of fixed? Sampling error. That's it. Within study error. That's it. So if that is what I'm assuming, my my overall effect size has come out to be 0.88. Okay, and if I go forward and if I go forward and change this, so in model you will find a drop down, and in that drop down you go to random effect, and the moment you go there, look at it, it's changed to 0.79. Right, so that's about the effect size, the changing in fixed, changing in random, the confidence interval, upper, lower limits, etc. And then there is, so this is the next important table which has to be reported, right? So there's a Q value, okay, and it's 0.005. So there's a P value, it's significant. I square is 99.32%. So obviously, I mean, it is 2 and 2, 4. There is heterogeneity. The tau square is not 0. Okay, so all values are in sync. for us to assume a random model. Okay, so I would go with the effect size of the random model, which is 0.79. Okay, so that's about it. And do you want me to, let me see if I can, for a minute, change some data and show it to you. I've just changed a little bit of data. Let me see. Yeah, so I just changed 2 of the data and just see the random effect fell to 0.68. Okay, so that's what I'm showing you, that based on the input that you give, it will show you the value. So what I've done is I've done nothing. I've just tried to fit a little with data. So I've just changed 2 values of 0.7 and 0.2. And the moment you change data here, I mean, this is a better software than CMA. At least in CMA, you have to go and then analyze and then run analysis. Here, you just don't have to do it. So see, I just input the data. I just gave it 2 different values, and here it has changed. It has changed, right? So minus 0.68, right? So that's it. Okay, now this is about the sheet. So you have so I've shown you 3 things. One, I've shown you of course you'll have to see Neeraj sir's videos on how this can be done manually on Excel. Okay, you have done it on a paid software, CMA. If you want to just take a trial for 10 days, try testing it, just see, play around, and then finally it is being shown in a Meta Essentials, which is of course the free and the most easiest of all the software. So you've been shown this in three methods of analysis, 3 different softwares. Of course, the results will be same. Don't worry, the results will be same unless and until. But you know what happens in the CMA? They go according to Borenstein's formula. So in some software, they might go according to Higgins' formula. So the formula might differ. So that is the reason in a research paper, whenever we are doing analysis, we always mention the software we've used. Okay, and further we mention the formula also. So I did submit one of my papers. Maybe I can share with you the rejection. It's okay with me. I'll just give me a minute. I'll just show it to you. So or maybe tomorrow I'll just let me go to the sample paper first, because that is what is important. And yeah, so this was my sample paper that I have been working on since morning. We are still on the same table. Okay, so now I hope all these columns are clear. So I'm still on attitude intention. I'm still, since morning, I'm only doing this one row, by the way. You can imagine the amount of work which goes into a meta-analysis paper. So attitude intention, total number of sample sizes 6117. K is 19, effect size 0.61, upper limit, lower limit, and Q value is this, and the 3 asterisks show that it is significant, and I square is 94.73. Now let me tell you the authenticity of this paper. So this paper is actually from a university journal. Okay, so Faculty of Science, Medicine and Health. It is from the university journal. So it's definitely an Australian university paper. So they have very prominently the part which I was telling you. They have very prominently shown the heterogeneity. Let me come to it. Yeah, so they're very prominently shown heterogeneity. Right, so They're very, look at the heterogeneity values. I mean, 94, 90, 95, 91. So if you want, I can just, give me a minute, I can show you a few more papers so that you know. And yeah, sorry, I have to tell you how to write also. It's not just that you show it in a tabular form. Okay, yeah, so let's start from here. So this was what we had written about effect size, if you remember. So he had calculated the effect size and said that the effect size is strongest for the attitude and intention relationship vis-a-vis others. Okay, so now he comes to heterogeneity. Okay, so he speaks that the Q was significant and I square was high. So there is a heterogeneity, and now we start, or we make a base of the next that we are going to do tomorrow morning, which is meta regression. Okay, so when there is heterogeneity and such a high heterogeneity, it is because of a factor, it is because of a variable. And now my next job is to find out that variable. Okay, so that is what is going to be done tomorrow. So it plainly says that this was my Q and this, and let me see if it has, it must have spoken about the software. I'm sure it must have, I think it is a comprehensive meta-analysis, if I'm not wrong. I'll have to find the software. Okay, so after he says that it is heterogeneous, he goes for moderator analysis. This is what we are going to do next. Okay, so he takes a few moderators. I'll tell you how to take moderators. It is very different. Moderators is nothing. He divides the data on the basis of groups. He's divided the data on the basis of age, and now he's going to check whether age is a factor which led to his heterogeneity, yes or no. So once he does that, that is when we go to meta regression, and further Kaushik sir tomorrow will take that. Okay, so now what's this? Just give me a minute. I have to show you a few more papers. Just give me a minute. I'm just sharing. I think someone in the morning was asking a question about the medical line papers, okay, scientific papers, which have an experimental group or a control group. So in front of you, you can see how do you report papers where the input is a standard deviation of mean, which is taken from an experimental or a control group. Okay. Now, while studying this paper, okay, first let me tell you the basics that have been reported. Okay, they do assume a random model. They have very clearly assumed a random model. Okay, this is the consolidated effect size, and what I was telling you right in the beginning was that whether your input is standard deviation or mean, whether your input is correlation, whether your input is odds risk ratio, after one point, everything becomes common. So look, when you are noting the effect size of each study, I mean, they are just reported the way they were reported in correlation. What difference do you see in reporting the effect size of each of the studies when you took a standard deviation and mean, or when you took a correlation? Number one, the same upper limit, same lower limit, the same forest plot. Okay, so after you put that input into the software and come with your outputs, the outputs and the interpretation of those outputs are same. Just one change is there in interpretation, and that is that when you are interpreting
this value. Okay, so this value interpretation is a little different when it comes to the Cohen D. Okay, so in Cohen D, in social sciences, where with correlation, where a higher effect size is above 0.5, in Cohen D or Hedges G, which is calculated from this sort of a experimental control study, in those type of studies, anything above 0.8 is considered a high impact. Okay, so there's just this one small difference in interpretation of data. Okay, and of course you see over here the rest of the things are same. There's a tau square, there's a chi, okay, there's a p-value reported, there's an I square of 45%. This person has been very lucky. Okay, so all those things are similar. Okay, and at some places, although just look at this, he says that at some relationships, of course, where he found 45%, he did find an 85% heterogeneity also. Right. So the first thing you check is significance, and after that heterogeneity. And if it's high, you report it. What I'm trying to say is that these are all published papers, and they are reporting a very high heterogeneity. So what you're trying to do, I reiterate, what we are trying to do is just describe a pattern of my papers. I'm not trying to manipulate data here, and neither should I try to manipulate. Okay, and so okay, there are a few points which you can give to justify random. For example, in this research, he chose random, okay, but he has not justified it by saying that because my heterogeneity was high, I went for random. So just read out how he has justified the random model. He says that the mental health outcomes most assessed were depressive symptoms in 15 papers, anxiety 14. So he's just justifying the difference in his papers, because of which he can see a high. This is how you report it in a medical paper. Let me find one more paper for you. Okay, in the morning there was one more question related to this topic which I wanted to answer, but I thought let me get a paper for it and then answer. So I'm covering that too. Somebody said that will we need a forest plot for, should we show a forest plot for all bivariate relationships? Okay, so see this is actually a research paper from the social domain. Okay, and this shows correlation values, upper limit, etc. So what this person has done is this person has shown a forest plot for each and every. So this is for one of his bivariate relationships. Okay, so if you see there is a correlation, and correlation will of course be for a bivariate relationship. Further, he's described also. Okay, so figure forest plot for, see, forest plot for attitude, intention, association. Okay, so he said, okay, this is my one bivariate, I'm showing you a forest plot. And this is one odd paper. Generally people don't report all, but I found it, so I thought I'll show it to you. And this paper is also on theory of planned behavior. I'm reiterating the theory of planned behavior, where we had somewhere around 3 bivariates. So somebody asked us that will we find all those 3 bivariates in all 31 papers? You might not,
but those three bivariates, if I rightly remember, attitude and intention, subjective norm and intention, PBC and intention. Okay, if these were the three bivariates, he's shown you a forest plot for each of these. Okay, so there is a forest plot, and he clearly says this figure is for subjective norm, and intention. Okay, then he goes further. This was one paper which I had saved it because and look at the number of studies. I mean, someone asked me how many studies. So just look at the number of studies. This must not be less than, if I'm not wrong, 20, 25 minimum for each of the bivariate relationship. Minimum 25 studies he's taken. Exhaustive paper. Okay, so this is a forest plot for PBC and intention. So this is one paper where for all the three important bivariate relationships, a forest plot has been shown for all three. Okay, and yeah, so forest plots, so there were too many. All forest plots he's shown. And you also to the another question which was asked, that do all the relationships come out of all the papers? No. In the past forest plot where you saw somewhere around 25 papers, look at these papers. I think these papers must not be more than 16 to 17. Okay, so every bivariate relationship that you do, it will not be available in all 31 papers. Okay, please make the Excel sheets as I showed you, and accordingly please make the forest plots. Now this is additional data we generally do not give, but and this data he's given towards the end of the research paper, so it's almost like an extras. Okay, so if you do want to give it, you can give it, and this is very good actually. You know, if there are amateur researchers like us, it'll be very good for us. I mean, we just have to take out this paper, Terry and Hogg 1996, pick up a correlation and see whether the correlation is between what and what. So of course we have to read the correlation table and take out the correlation between intention and behavior, and then list all these papers, and we could calculate this ourselves to know if we have understood the calculation of effect size and heterogeneity, etc., ourselves or not. Okay, so that's about a few papers. Okay, yeah. This is a funnel plot. I'll explain this when I'm doing publication bias, but I found this paper really interesting because this guy had given a funnel plot for each of his bivariate. So exhaustive data he's given in an extra. So he's given a funnel plot, which is generally for publication bias. Even that he's given for all bivariate relationships. See? So he's given a forest plot and a funnel plot for all bivariate. So this answers your question that can I show all the papers. Okay, and one last thing that I would want to show you. Okay, I just wanted to show you the just showing you the sample I wanted to. Okay, yes, this is what I wanted to show. So the software that you use has to be specified in the paper. So you can see over here, it's not just listing values. I've showed you listing values, but look at the amount of calculation that you have to write. So, you know, this was one part I really missed on, and the editor really wrote to me. So if you give me 1 minute, I will actually show you the sheet, you know, where the editor has written what was wrong in my meta-analysis, you know, and I'll actually show you that sheet. I want to show you that sheet, and I want to show you how we sent it back to him. So see, this is all doing work. Once you submit, it's a different ballgame altogether. So this was something I did not include. You know, what I did is I reported the fixed effect, I reported the heterogeneity, I reported the heterogeneity tables, I wrote that as per Cohen, effect size is high or effect size is low. So that is all I reported. But how I calculated it, I thought probably Now the editor, sorry, the reviewer who's checking the meta-analysis paper probably knows what is heterogeneity and how it's calculated. Okay, so all I have to write is that I did, there was only one line that I added. I should have added all this, but I added only this one line. I said the calculation has been done according to comprehensive meta-analysis version so and so, Borenstein 2014. This is the exact line I added, and I thought I'm done. I thought he'll understand, but the paper came back with this comment saying that you're supposed to be explaining the calculation. So just take a minute and see this calculation of pooled effect size was through so and so. He's assumed a random model. Random effect meta sizes was used because of significant heterogeneity, says Borenstein. So this is the reply to how we decide heterogeneity and which model to take. So Borenstein is one model, one author which this person has quoted to pick up a random effect, and the basis of that, he says, is significant heterogeneity. So this is what I was saying. Okay, so whereas in the other paper we saw, he did not defend it this way. He said, I assume a random effect because 10 of my papers are from here and 20 are from there and 5 are from there. So he was justifying the between study variance in his paper. Okay, and from where it is coming. Is it coming from research methodology or location, etc.? Whereas this author says that I am not justifying. I'm just saying that the significant heterogeneity is there, and thus I'm going for a random effect model, and it is according to Borenstein. Okay. Also, he quotes another author, Hedges, and they're very old authors. Yeah, the Hedges G is on this person's name. So he also quotes that random effect meta-analysis allows the result of meta-analysis to be generalized beyond the included study. So he's again taken the heterogeneity point. We estimated the heterogeneity across study using both Q and I square. He's also defined, again, he's taken it from Borenstein. Even my slides are from Borenstein. So thus the value is same, 25%, 50%, 75%. Okay, so Higgins and Borenstein, he says Q value from Borenstein, these values from Higgins 2003. So he's actually shown how he's made those calculations, and all this is needed. Okay, all this is needed. So if you would want to see one of my papers, because I think that is an add-on. I don't know how many of you, if you're attending this for the first time, I really don't know how many of you will go for writing a paper and then the papers don't get through editors, and then finally they get through editors, and then finally they go to reviewers, and then you get a sheet like what I'm about to show you. You'll have to give me 1 minute, just 1 minute till the time I get that sheet, just 1 minute. Just 1 minute, I'll have to get it from my email. I wanted to show it to you. I hadn't planned it, but because we have time, I think I can take 5 minutes and show it to you. I'm just, okay, by the time, can we start with questions till the time I search it? Because I think we can start with questions, and I'll just, I'll take time to get to the sheet. So I can